Everyone wants to learn PySpark because of its growing demand. But do you know what? The dynamics of PySpark are totally changed because of this new package called Spark Declarative Pipelines. And let me tell you one thing, this is not just a random or small upgrade. This package has changed the way of writing PySpark code, and you will see this skill flooded in the job descriptions very soon. Now you will say, hey Ansh, we also want to learn this package. We also want to learn how to write the code using this package and so many other questions. And you know what? This 4 hours long complete Spark Declarative Pipeline course will answer your all the questions, because this course has covered everything you need to know in the world of Spark Declarative Pipelines from scratch. And if you are someone who always worry about job security and what will happen in future to your job, then I can say that if you complete this video and follow all the instructions given in the video, you will be able to become an outlier by the end of this video in this competitive era. The best thing, you do not need to be a pro PySpark developer in order to continue with this video. A very basic understanding of PySpark is enough to get started with this video. And the best thing, all the notes and all the code examples are provided with this video so that you can just follow along. Just hit the subscribe button right now before starting with this video, and let's get started with this amazing masterclass, and let's become an outlier in this competitive. So what's up my fam? Happy Sunday. I hope that you are enjoying your Sunday, and this Sunday is very special because in this Sunday we're gonna talk about Spark Declarative Pipelines. By the way, this is a very hot topic right now. Why? Because Apache Spark is the heart of data engineering, is the heart of data engineers, and finally we have a new addition in the world of Spark, and I just call it as a new era of Apache Spark, new era of coding PySpark. So obviously this requires a special dedicated video. Ansh, Lamba, do you know what? When we clicked on this video, we had so many questions in our mind. Let me just quickly ask those questions so that you can save your precious time, because you will say, Ansh, Lamba, we do not need to know like if we should watch this video. So I know you have so many questions. Let me just quickly cover all of those questions. Spark Declarative Pipelines. Is this topic similar to Delta Live tables? Short answer, yes. Smart answer, not really, because there are so many add-ons in the Delta Live tables concept, and now the Delta Live tables is renamed as Spark Declarative Pipelines. It is not just a rename. There are so many APIs that are added. There are so many syntaxes that are renewed. There are so many decorators that are changed. There are so many things. But the good thing is, if you already know Delta Live tables, you can watch this video and you can just treat it as like a binge watch, where you will not be doing much hands-on, where you will not be doing much, you can say, coding, because you already know Delta Live tables in detail. So you can treat it as a binge watch, and that's all. If you do not know anything about Delta Live tables, if you didn't even hear about this word, then do not worry, because this video is for you. That is why I've created this video. Because see, Delta Live tables, I know like a lot of people know already about Delta Live tables, but there are so many people that do not even know about Delta Live tables, and now Spark Declarative Pipelines. So bro, this is the material that they need, all those data engineers. So what are the prerequisites for this video? There are some prerequisites. Okay, there are some prerequisites. So prerequisites are, you need to have some basic, very basic PySpark knowledge. If you have worked with PySpark, if you have written some code within PySpark, you are good to go with this video. And I hope that if you are a data engineer, you would have written some code in PySpark. You would have some basic understanding of PySpark. This is like very basic thing that I would expect from anyone if the person is a data engineer. Okay, so if you have that very basic understanding of PySpark, you can continue with this video. Both the questions are solved. Question number 1, is it related to DLT? Is it same as DLT? It is not exactly same as DLT, but the core fundamental, the backbone is same. If you already know DLT, you can treat it as a binge watch. If you do not know anything, then there's a great news, because everything is covered from scratch. You will be doing lots of hands-on, lots of labs, everything. Okay. So now you have clarity about this video. Now it's your decision if you just want to continue with this video, because I can guarantee one thing. Those who will just complete this video will become an outlier in the today's era of data engineering, and this new addition in the world of Apache Spark will create a difference, will create a real difference. Just wait and watch for the industry to react on this. But you know what? My data fam gonna proactively do the work instead of reactively. Okay, so that's why this video is for those, and they're gonna learn so much of things. By the way, let's discuss the agenda of this video. So in this particular video, we're gonna quickly look at Apache Spark, we're gonna look at PySpark, we're gonna look at what is SDP, why SDP, components, so that you can just build a strong fundamental base, because I do not expect any prior knowledge from you in the world of declarative pipelines. I do not expect any kind of prior knowledge in the world of delta live tables. But yes, if you have that knowledge, you can totally skip these chapters, SDP, YSDP and components, and all the timestamps are there in this video, okay, in the description. And if I were you, I would have still watched all the chapters, because I wouldn't know what is new in a particular chapter. That is why I told you, if you already are familiar with delta live tables, treat this video as a binge watch and you will learn a lot of new things, trust me. But again, decision is yours. What did you say? Decision is yours. Okay. Then we're going to talk about flows. Then we're going to talk about streaming tables, materialized views, sinks, append flow, auto CDC, expectations, jobs, SCD types. In short, if you complete this video, okay, by the end of this video, you will be able to understand, you will be able to implement, you will be able to develop everything with respect to this new addition in the world of Apache Spark with ease. Because I will explain you everything with the help of visuals, graphics, coding, labs, everything. All the installation, all the machines, everything. Machines, like whatever you are using, okay? Make sense? Very good. I am really excited to kickstart this particular masterclass, because this is something which will help you land your dream job this year. And I'm not kidding, because this is a kind of change that happens once in a decade, I would say. Not even decade, I would say once in 5 years at least. I still remember the biggest update that we received in Apache Spark was Apache Spark 3.0, where we received adaptive query execution and all those optimization techniques that we received around Apache Spark 3.0, and that changed the dynamics of the data engineering industry. And now after 3.0, 4.0, Apache Spark 4.0, because we have, or not like 4.0, I think the latest one is 4.1. So in the 4.1, we can say that this is again the change that can shake the industry. Literally, because you didn't even work with Spark Declarative Pipelines, SDP. That's why you do not know the power of it. Okay, and if you just want to double sure like what is the future of SDP, just go to your favorite chatbot, ChatGPT, whatever. Just ask, hey, we have heard about Spark Declarative Pipelines. Is it worth to learn? Is it worth to spend time to learn that skill? You will get the answer. You will get the answer. Just go and check it out. Okay, so I'm just dropping this first ever YouTube video on Spark Declarative Pipelines, because recently Databricks has contributed this amazing framework to Apache Spark. So that is going to make a real difference. Make sense? So this 3 hours, like this hardly like 3 hours, can actually make you an outlier in today's era. Because competition is everywhere. Everyone is trying to enter into the data engineering domain. So many teachers are just trying to teach data engineering, because data engineering is like currently the hot topic. But I will say just one thing. Okay, I will not say someone bad, someone good, because I am no one to say anything. But I will say just one thing to my lovely data fam, because I do care a lot about them. Choose your mentors wisely, because right now everyone is teaching data engineering. Okay, but I will say just choose your mentors wisely. That's it. That's all I can say. I'm not forcing you that you need to follow this guy, you need to follow that guy. No. You are smart enough. Follow, or you can say choose your mentors wisely, because that they will shape your career. They will just make your career. I'm just telling you this thing. Because currently there is a trend. If you want to become famous, if you just want to gain some views, just teach data engineering. Even if you are not in the data engineering domain, you are, let's say, in data science and data analytics, just teach data engineering, bro. Come on, man. Come on. We are not saying like you should not teach data engineering, but bro, my data fam, you need to choose your mentors wisely. Okay. That's it. That's all I can say. Okay. So now let's kickstart our video, kickstart our masterclass. And before that, you know that this is my favorite part. So let's congratulate my lovely data family members who have recently cracked the data engineering offer letters and cracked their dream jobs, and they're happy. So I am happy. So congratulations to all of you. I'm really, really happy. Now you will say, what did they do special that they cracked the offer letters? They followed the right mentors, right? So simple. So congratulations to all of you, my lovely data fam. I think I got some LinkedIn messages as well, so I forgot to add these messages. But yeah, these are the comments, YouTube comments. You can just simply congratulate to these people. Congratulations to these people as well. Congratulations. And finally, Ansh Lamba handles. So these are my handles. If you just want to, let's say, follow me, you can just go and just check these handles and I will be there. Okay. So I'm really, really excited to kickstart this video. And if you are also excited, just take out your notebook, because in this particular masterclass, you're going to learn a lot. And the best thing, all the code examples, all the notes, everything will be available in the GitHub repo, and the GitHub repo link is in the description. You can just go and just download the notes and all the code blocks. Make sense? Okay. Very good. Let's get started. So now we are talking about Spark Declarative Pipelines. So obviously we first need to quickly talk about what is actually the Apache Spark. Like everyone knows about Apache Spark, but let's quickly cover this topic as well. So Apache Spark is a kind of framework that helps us to perform distributed computing. Distributed computing, what does it mean? So let's say I am a developer, okay, and I have big data, very big data to process. So let's say I have the data, and this data size is, let's say, 1 terabyte. Okay, 1 terabyte. Now I want to process this data. And in order to process this data, I have two options. Okay. The first option is like the traditional approach. I can use the distributed computing. Okay. Distributed computing using MapReduce. Hadoop MapReduce. Okay. Hadoop MapReduce. Okay, this was a traditional approach to process your data in a distributed manner. Make sense? So Hadoop MapReduce was absolutely great framework to process our data, where it used to distribute the data. Make sense? Because we cannot just process 1 terabyte of data in one go. We need to distribute our data, distribute our load. So we used to follow something called as Hadoop MapReduce, okay, which used to distribute our data. That means mapping and reducers. Map used to, you can say, distribute the data, and reducers used to collect that information and aggregate that thing and return the results. Okay, Hadoop MapReduce was used to do this thing. Makes sense. Now, what was the drawback of it? This approach? It was writing the intermittent results to the disk. And every time if we just want to use those results, it used to go back to the disk and get the results and then store the results again, then go back. And this to and fro motion used to take a lot of time. Then Apache Spark came into the picture around 2008 or 9, I guess. And they said, hey, you are processing your data in a distributed manner. That's fine. But why are you writing the results again and again to the disk? You can process everything into the memory, into the RAM. Into the RAM. So that's where the concept of distributed computing became more efficient, when we started processing our data into the RAM instead of the disk. Yes, sometimes we still write our data to the disk. That is called spilling. But that happens, I would say, rarely. Okay. Not every time. Make sense? So this was the whole difference, or you can say the triggering point of including Apache Spark into the world of distributed computing when we were using Hadoop MapReduce. Make sense? And obviously, this is not like Apache Spark Masterclass. If you just want to learn Apache Spark in detail, if you are not a pro Apache Spark developer, just go and check out my YouTube video. It's called Apache Spark Full Course. Just go to YouTube and just search Apache Spark Full Course. I can just show you here as well. So if I go to Google, I will simply say Apache Spark full course Ansh Lamba, and you will find this video, amazing video, Apache Spark, the ultimate guide. This will teach you everything. This is like 6 hours course for free on YouTube. You will learn like everything that you need to know in the world of Apache Spark, and that's it, including theory, including lab, everything. Make sense? Yeah, but I just gave you a very quick overview just to revise the concepts. Make sense? Good boy. Good girl. So this was Apache Spark. Now, okay, this was a kind of architecture or framework that you were using, but what is PySpark? What is PySpark? PySpark is nothing but a kind of Python API, or you can say Python wrapper on top of your Apache Spark. Okay, because obviously Apache Spark is a kind of framework. Okay, it is not a way to write the code. It is just a framework. Now, in order to write the code, we started writing code in Scala. That's why you see Scala in a lot of job openings, but now I think that is going away because Python is everywhere. And in the world of AI, Python is even more stronger. So then after launching Scala, after basically launching Java, they just built the Python wrapper as well so that they can attract Python developers as well to do the coding. Make sense? So what you do, let's say this is you. Okay, this is you and you are a data engineer. You will do everything in Python. Like not exactly Python, but you will write your PySpark, you will write your Apache Spark code with respect to Python framework. You will use Python library. It's called PySpark. So basically PySpark is more of a kind of module that you use to do your work with Apache Spark. So this Python module is linked to this Apache Spark and you just interact with Python. You just interact with Python. You write your code in Python. That's it. But behind the scene, it is connected to the Apache Spark framework. And there are some APIs built in which perform the transformations and everything. All the Apache Spark execution plan, logical plan, physical plan, everything will be done under the hood automatically. But you will just use this Python package. So you interact with Python package, Python module to get your work done through Apache Spark. And that package name, that module name, that library name is called PySpark. That means Python plus Spark. This is PySpark under the hood. Now PySpark has been the traditional way to write your code. Are we saying that PySpark is going away? No, not really. But your way to write the code using PySpark will be changed after SDP, which is Spark Declarative Pipelines. Because earlier, developers used to write the code using PySpark to apply the transformations. That was one part of it. The other part of working with Apache Spark was optimizing the jobs, Spark jobs, optimizing the code, distributing the data among partitions, coalescing the data and so many other stuff as well. That was the other part of it. So now SDP, Spark Declarative Pipelines, will take care of the rest of the part. That means the second part. You just need to work with the first part. That means if you know PySpark coding, that's it. You do not need to know the other thing, the second part of the Apache Spark, which is like optimization of Spark jobs. And currently, almost every developer knows PySpark. They know how to code in PySpark because now we are in the AI era. They can simply go to the chatbot. They can simply get the transformations. Now we have the AI assistant in the IDEs, in the, you can say, code editors. You can easily get the code for PySpark to do anything, literally do anything. Okay. Now the difference was people were selected for the jobs who knew how to optimize those jobs because everyone knows how to write PySpark code. Now, what will be the deciding factor? Because you do not need to optimize the jobs, obviously. Now the deciding factor will be the people who know SDP, how to write PySpark code with respect to Spark Declarative Pipelines will be selected. Because they do not want those people who can optimize the jobs. No, they do not need those people. They need those people who can work efficiently with Spark Declarative Pipelines. This is the new era of Apache Spark. This is the new era of Apache Spark. Make sense? Make sense? Make sense? Yes, you still need to know PySpark. That is the base, that is the fundamental. You need to know how to apply filter, you need to know how to apply join, you need to know how to apply union, group by, aggregations, all those transformations. Everything, you need to know this, but you do not need to worry much about those optimization techniques, partitions, coalescing, salting, all those things. Okay. Okay. So that is why if you know a little bit about PySpark, you can continue with this video. And a tip, a bonus for you, if you want to master PySpark, that I believe you should, even if we are living in the AI era, if you master PySpark, it will benefit you. Okay. So what you can do, you can simply go to this particular browser, whatever browser you want to use, simply search PySpark Ansh Lamba, and you will get a dedicated course on this as well for free on YouTube. This is called PySpark full course, which will teach you PySpark coding from scratch. All the functions, all the transformations, joins, filters, whatever you want to do, just go and master PySpark, because PySpark obviously is like, PySpark is always there. PySpark will be there. You need to code the things, right? So you can just master this thing using this particular course. Now I assume that you have some basic understanding of PySpark, okay? Just basic. And if you do not have the pro skills of PySpark, but you have the resource, so you can just watch this PySpark video after completing this video, okay? Make sense? You have the resource now. And if you want to master Apache Spark in general, you have the resource for that as well. But for this particular video, you just need very basic understanding, because SDP is totally a different concept. You first need to understand how it works, right? So let's see, what do we have inside SDP? What the stuff it is doing. I know it is a new name, new concept, new framework, new addition. Everything is like crazy, and you're gonna love it. Just be with me for these 3 hours, and you gonna become an outlier, a totally different person after this video, because this is going to be a game changer thing. Mark my words. Okay, let's get started. So bro, we know that Spark Declarative Pipelines, aka SDP, is very popular, will become even more popular, and mark my words, it will become the next big thing. Because if you remember, when Apache Spark was really new, PySpark was really new, a lot of people started learning about that particular technology, because people knew that it will burst in the future. And you know what? Now PySpark has like such a great audience, such a great number of users. Now just think about SDP. Obviously, SDP is the next big thing for all the types of data engineers, because, or not just data engineers, for all the data domains, because PySpark is now being used in all the data domains, because SDP is the future. Trust me, it is the new era of Apache Spark, is the new way of writing code, and you will know everything. Okay, so I know this is the first question that comes in your mind. Okay, what is SDP? We know that it is a game-changing thing. We know that it is a very good thing. Okay, sorted. But what is SDP? Even before learning about SDP, we first need to know what is SDP, so that we can take a decision whether should we learn this or not. Okay. So first of all, SDP is nothing but, it's a kind of framework. Okay, it's basically a kind of framework. So if you have like worked with Apache Spark, or let's say PySpark, I can just use these two terms interchangeably. Okay, so if you have worked in you can say framework which uses Apache Spark, PySpark, we do two things. Okay, what are those two things? First of all, what part? What part? That what we need to do with the data. We want to transform our data. We want to filter our data. We want to apply some groupings on our data. We want to aggregate our data. This is the first part of it. What? Then we also think about how many partitions we need to create so that our Spark job runs fine. How many executors do we need? How much of memory we should allocate, and all those things, right? Yes, right. Obviously, that's how we just run our Spark jobs. But SDP says you just need to focus on one part, which is called what. What part? That is it. That is it. You just need to focus on what you want with, like, what do you want to do with your data? You want to transform your data? Okay. You want to filter your data? Okay. You want to aggregate your data? Okay. But you do not need to worry about how Spark executes it under the hood. Okay. This is called a declarative framework. This is called declarative framework. Okay. That means you are just declaring it what you want. That's it. Nothing else. Nothing else. Okay. So that means all the overhead that you used to handle before for Apache Spark, for all the Apache Spark development is gone. So just tell me now, is this revolutionary? Yes. Will this become a big thing in future? Yes, because it is already a big thing in the present, and just think about the future. Because companies do not want to spend resources just to figure out how we can optimize our Spark jobs. They just want resources to get the work done for their development. They just want resources to write the code, and that's it. Why do you want to put some extra time, extra efforts, extra resources to optimize the Spark jobs? Why? Like, obviously it was a big thing in the past, but not now. Especially starting from 2026, it's gonna blow up. I am so sure. Okay, so let's also look at some comparisons. I have already mentioned this, but it is just for your notes. So unlike traditional imperative programming, where you give step-by-step instructions, declarative pipelines let you define a series of transformations and actions on your data in a clean, readable way. And with the help of SDP, Spark will figure out the most efficient execution plan. And I hope like you know about the execution plan, because whatever code we write in Apache Spark will get first translated into logical plan, and then that logical plan, like first it gets transformed into unresolved logical plan, and then logical plan, and then physical plan. And companies were like stressing on these things, like how we can just optimize our things, and how we can just do this thing, how we can just do that thing. So now Spark will do everything, including those logical and physical planning, plus all the extra plannings that resources were doing. Partitioning, memory optimization, and all those things. Wow. Literally wow. This is SDP under the hood, and I personally love it. I know you will say like we already have like delta live tables, or we already had delta live tables, how it is different. So the underlying architecture is same, but currently, as I just mentioned earlier as well, Databricks has, you can say, contributed this project into Apache Spark, because Databricks knows like this will become a big thing, and this will actually resolve the bigger problem in the industry. Makes sense? So there are so many changes. There are so many things that are updated. So you need to know everything. And I thought of like, let's create a video for SDP, which will be aligned with Apache Spark, PySpark, and everything which is related to Spark, right? Makes sense? So this is SDP under the hood. And this is just like the 1%, the tip of the iceberg that we have touched. When we will go deeper, you're gonna love this, because obviously we're gonna just do a lot of hands-on as well. We will be writing a lot of notebooks. We will be just writing code, everything. You're gonna love that. Okay. So this is SDP, and I hope now you understood the concept of SDP, Spark Declarative Pipelines. Got it? So now comes the point, why SDP? Okay. You can ask this question. You can ask this question. You can ask this question. Anyone can ask this question. Why SDP? Okay, we know that it is very good. Okay, makes sense. But why? Why SDP? Okay, valid question. By the way, valid question. One of the biggest advantages of declarative pipeline is that they remove a lot of traditional overhead in Spark jobs. Okay, so usually when you write Spark code, imperatively, you spend time manually creating partitions, coalescing data, caching tables, tuning performance. So, for example, you are just writing some data. Okay. So, obviously, in order to write that data in such a way that you can query the data with much more performance, or you can say with better speed, you create partitions. Then let's say you have so many partitions within your data. You can also coalesce the data before writing it. There are so many optimization techniques available within PySpark, and that is why PySpark was such a niche area that only experienced people were tapping into. Only those people were like becoming that 1% of the group where you need to perform those advanced level optimization techniques, because these techniques, obviously everyone can learn that, but these techniques will be inherited in yourself with practice, with more and more, you can say, implementation, by making more and more mistakes and by making more and more learnings out of that. So that is why Spark was such an area where you would see we need someone with 10 years of experience, we need someone with 5 years of experience. But why the domain has started shifting, that even for the fresher roles they just put we need PySpark, we need Spark developers, because so many advancements are here, and all those you can say optimization that only senior people used to do now can be done by Apache Spark without using those things. But now just think about the domain that we are going to experience very soon with SDP. You do not even need to perform some basic optimization such as partitions, coalescing, caching. These were like very basic things. Now Spark is saying, bro, you do not even need to perform this thing. So now what will be the advantage of thing, and what it will contribute in the data engineering domain? So I can say that it will directly open so many job openings, because you do not need to have that 10 years of experience, 15 years of experience, five is fine. Okay, 5 years experience is fine. But yeah, 10 years of experience, 15 years of experience, you do not need that. No, you just need to know how to write the code, and that's it. And you can easily learn that, like it's not a big deal. But yes, you need to know one thing, how to use SDP, because if you do not know how to use SDP, you cannot like perform all the stuff that only senior people used to do. Makes sense? And that is why we have this video. So basically, declarative pipelines handle these optimization automatically. You do not need to worry about any low level mechanics. Spark figures out the most efficient way to process your data. Okay. That is why now you do not need to you can say spend your time in learning all those optimization techniques, how to fine tune the job, how to fine tune the performance. No. Now you just need to know how to use Spark declarative pipelines, and that's it. Everything will be done automatically. Okay. So now let's see one example. Not example, let's say a kind of real-time scenario. So now let's say you are writing the code. Okay. You are writing some transformations within your, let's say, notebook, whatever. You do not have to worry about execution details like task scheduling, memory optimization. Instead, you describe a flow of operations. Now, what are flow of operations? Basically, transformations, filtering, joining, aggregating, and Spark handles the rest. This approach reduces bugs because you do not need to do anything other than just defining what you want to do, and it improves performance as well and makes your data pipelines more robust because you are not handling this thing. The people, or basically the frameworks, mini frameworks which have actually built Apache Spark, they will be handling those things, and they know the best techniques to handle those things. Okay, better than you at least. Okay, better than me as well, better than anyone else. Okay, because they know like how to do the things, right? Make sense? Okay, makes sense. Now let's take an example. Imagine you want to process a sales data set, and obviously if you are working in an organization, you will be just processing some data. And for example, you are working in a product based company. Oh, I know that's your goal, but yeah, I believe that you will be working in a product based company very soon. Don't worry at all. Does that mean service based companies are bad? I'm not saying this, but I know like everyone wants to work in a product based company because you get better experience, right? Okay, again, it's your personal choice. So imagine you want to process a sales data set, okay, to find the top products by revenue. And it's a very basic requirement that you can get from your manager. Sorry. In a declarative pipeline, you would describe the operations like this. How? First of all, you will read the data set, Then you will filter for completed orders, obviously, because you do not need to include the cancelled orders. Then you will calculate the revenue. Okay. Then you will group the data by product, and then you will just sort it. Then you will write the results. That's all you will do. That's all you will do in terms of writing. That's it. That's all you need to do. You do not tell Spark how to shuffle or partition the data. It decides the best way to execute your plan efficiently. And do you know what? Writing this PySpark code is not a big deal. It's not a big deal. But yes, you need to learn how to write this code with the help of SDP as well. That's a big thing. That's a big thing. You need to know this thing. But all this overhead will be gone. We do not need this. We do not need this. Make sense? Make sense? Very good. So now, does it only mean that it only reduces the optimization techniques and all those stuff? Not really. What do you mean? We need to write the code, right? Like all the code that we are writing now. Not really. So declarative pipelines, SDP, also reduces the code. How? How is it possible, bro? So a very good example. For example, let's say declarative pipelines. Okay, you are using declarative pipelines, and let's suppose you are not using declarative pipelines for now. Let's say you are using a traditional PySpark code. Okay, and you want to create a notebook for building a slowly changing dimension type 2, which is a very common request for any data engineer, and you should know about slowly changing dimension. Okay, what is a slowly changing dimension, especially type 2, because type 2 is a type of slowly changing dimension which requires the most of the code. Okay, which requires you to write a lot of, you can say, code blocks just to implement that solution. But you know what? Spark declarative pipelines have something called as, for now I can just call it as, let's say, API. They have some special APIs which can reduce your slowly changing dimension code into just few lines of configuration. That's it. And I will just show you as well with the help of an example. Okay, but for now you can just understand this concept conceptually. Okay, so for example, we have this particular API called auto CDC. Okay, with declarative pipelines we can leverage tools like auto CDC, okay, which handle these operations automatically. That means slowly and slowly all that boilerplate code that you used to write with the help of PySpark is now being optimized as well. So it's not just like optimizing the memory. It's not just optimizing the data. It's also optimizing the code. Why it's a big deal? So let's say you are a developer A. Okay. So let's say you are a developer A. You have written the code, okay, for slowly changing dimension type 2. You are developer A. Okay. And let's say you wrote 500 plus lines of code, and I think it's normal if you are just building a slowly changing dimension type 2, it's normal because you need to just develop in such a way that it can be reused as well. Okay, so let's say you are a developer A. Now you are very happy because you built that. Now your same notebook should be used by others as well because they do not need to build the same thing again and again. So now let's say there's a new developer B. And the person says, bro, my coding style is different. Your coding style is different. So can you please explain me the stuff? You explain this thing to him. Okay. Somehow. Okay. Makes sense. Now you made some changes. Let's say after 1 month, after 2 months, you found a bug or anything. Then again, this thing, you will explain the stuff to him. Okay. And after some time, you will be very, very frustrated. You will be very, very frustrated and you will be like, hey, just go away. I'm not explaining you anything. Just go away. So you will behave like this, right? Because you cannot explain the same stuff again and again, and you have to explain this stuff because you have created the notebook and your coding style is different than others, obviously, right? And now I know this is not the case for every time. Let's say there's a new developer joined your team, and okay, and this new developer is a female. And now if she asks you 100 times, obviously you will say, yeah, sure. Let me just explain you the code and see, this is how you do it. You will add on so many stuff as well after that. So, but just think about this boy, man. Just think about this person. Just think about this person. So Spark Declarative Pipelines solve the problem for this as well. They have solved this problem. They said, bro, We know like everyone's coding style is different, so we do not need to worry about everyone's coding style. Let's create a kind of framework which can take care of these lengthy boilerplate code as well, which is called, let's say, slowly changing dimension. So this way anyone can understand this code. Why? Because there is not actually a code behind it. Like obviously behind this API there's a code, but on the front end side there's just a auto CDC API. I know. You are thinking like what this guy is saying, because you are not actually seeing the code right now, but you do not need to see the code. Just understand the concept. That's it. Once you understand the concept, then you'll be ready to understand the code as well. Okay. If you understood the concept, okay, tap your back and say, well done. That's it. Sorted. Okay. Makes sense. So now let's discuss about, it's time to look at the key components. Okay. So whenever we just talk about Spark Declarative Pipelines, we need to first of all understand the key components of it, because I always say fundamentals are everything, right? And if I just talk about the fundamentals of SDP, you need to understand the key components. The very first key component, and I would say the backbone of Spark Declarative Pipelines, are flows. Okay. What is a flow? Flow is the foundational data processing concept in SDP, which supports both streaming and batch semantics. What does it mean? So basically, let's take an example. Whatever we do in PySpark, the overall agenda of everything that we do within Spark is like we read data from something, like from somewhere, we process that data, we write that data to a target. This is like very high level, you can say, architecture of any PySpark code. Agree? Everyone? Okay. This is the high level architecture, or you can say high level goal. Make sense? So flow is that particular component of SDP that you need to use whenever you want to perform that goal. That means a flow is nothing but just a terminology that we use within SDP, which is Spark Declarative Pipelines. It will read the data. A flow reads data from a source, applies user-defined processing logic, your transformations, filtering, cleaning, whatever, and writes the result into a target. When we combine everything, reading, transformation, writing, it becomes flow. Make sense? Flow. That's it. Okay. And I have also attached the official documentation with everything, because obviously this is a new thing. So you can also just check and read the documentation, because that is the source of truth. And I always recommend to just go and just read about it. And if I just open that particular thing quickly, so you will see that you can refer to documentation. One is like official Apache Spark documentation, and one is like by Databricks as well. So both are amazing documentation. I prefer both. Okay. So let's try to read something for flows. If you will read this, so you will see that a flow is the foundational data processing concept in SDP that I just mentioned, which supports both batch streaming and batch semantics. That means we can perform stream processing and batch processing. Currently in the industry, we are more inclined towards batch processing, but slowly we are just getting inclined towards stream processing as well, because that is the future, right? Flow reads data from a source, okay, and apply logics, whatever, and writes the result into the target. Perfect. Now, do you know what? SDP shares the same streaming flow type. If you have a little bit of understanding of Spark structured streaming, you would know that we have three major types within the Spark structured streaming, which is append, update, and complete mode. Okay, very fundamental thing. Currently, with SDP, we can only perform append, okay? And there are some more flows as well that we'll just talking about, auto CDC, which is for, let's say, upserting the data and all those things. But you do not need to worry about that thing for now. You just need to understand what is flow. Flow is nothing but, you can say, your end-to-end logic, reading, transformation, and writing. Sorted? Very good. That's it. And you can also read this thing from this official Apache Spark documentation, which is just updated today, because till yesterday it was like a little bit different. Obviously, like in the world of data engineering, they keep on changing the stuff, and you can obviously read everything what is SDP. They have some cool diagram as well that you can just use while making your notes, and I appreciate that. So you can also do that, or you can anytime come to this website and just have an updated view. Yeah. Okay. So if you just read the flow, and you will find the same stuff here. Make sense? Okay, that's it. That's it. That's it. That's it. Now, after flows, we need to understand another component which is very important, which is called data sets. Now, what are data sets? What are data sets in general? Data set obviously is something which we can just use it to query. Okay. Data set is something that is holding some data. Okay. Similarly, data set, the concept is same. So data set is a queryable object, but that is the output of the flows within a pipeline. What does it mean? So for example, we have just discussed the flows, right? Yeah. Flows means end-to-end work, reading the data, transformation, and writing the data to a destination. Makes sense. Now, whenever you are writing the data into the destination, you will create something, right? You will create something. You will either create a table, you will either create a view, you will either create something. Makes sense. Like, what is your destination? It can be a table, it can be any object. That object is called dataset. That object is called dataset. Currently, there are three major datasets available within the SDP, and those are number 1, streaming table, number 2, temporary view, number 3, materialized view. These are the top 3 datasets available for now within SDP. What does it mean? So that means whenever we are creating a flow within SDP, we can either create a streaming table, we can either create a materialized view or a temporary view. Okay, there is one more data set which is newly added. Okay, we will also talk about that thing as well. It is called sync. Now, what is sync? Sync is, let's say, when you do not want to create any object similar to tables, but you just want to dump your data in the cloud storage. Let's say you just want to dump your data or write your data in just the cloud storage. Let's say Azure data lake. That's it. So that is the concept, that when you just want to create a sync, that's it. Okay, this is newly added. We will also talk about this thing as well. So you can just mark it as the 4th type, but these are the top three, or you can say the most popular data sets available within SDP. Make sense? Okay, very good. So these are the 3 outputs of your flow. That means whatever you will do in SDP, you will either get a streaming table, materialized view, or temporary view. We're gonna just talk about these things very much in detail, because we just write everything that revolves around these 3 objects. Okay, and just a quick one, we have a quick summarized version of stream table, mat view, and temp view. This is very useful for your notes. Okay, that's why I've created this slide. So let's quickly read it. Stream table. A streaming table is a form of Unity catalog managed table. Okay, I'm just talking about this thing from the Databricks point of view, because in Databricks we have a catalog, Unity catalog, right? Good. So streaming table is a form of Unity catalog, or just forget about Unity catalog. You can say a streaming table is a kind of managed table, which is a managed table that is also a streaming target for Lakeflow SDP. What does it mean? So we have just discussed that the output of a flow will either be a streaming table, mat view, temp view. So when we are saying that the output of our flow is a streaming target, similar to Spark structure streaming, okay, that's why it is called streaming table. If we want our target to be a streaming target, then we will create a streaming table. Simple, nothing else, simple. Okay, now then, what is materialized view? If you know about materialized view in general, like what are materialized view in general, because this is a SQL concept. In materialized view, yes, we run the query, but at the same time we store the result of that query as well. Similarly here as well, materialized views are used to create the managed table, but for the batch target. This is not a kind of streaming target, batch target. Oh, okay. And do you know the best thing about this materialized views? In general, when we have materialized views, we recompute the data every time, right? Common sense, because we just recompute the query, right? Whatever the query is saved in the view. But here, within SDP, most of the time, it will not recompute everything. It will only compute the latest data, or you can say the new data. We will just talk more about that thing as well, but I'm just giving you some hints. Okay, then temporary view, this is the normal view that you create. Okay, like it just holds a query and that's it. It does not store any data. It's just a view. And yes, we like not we like SDP supports both the kinds of views. You can say, yeah, you can say we as well. We support both the kinds of views. You can say first of all is a normal batch view and streaming view as well. Okay, don't worry, this is a just high level overview of the concepts and that's it. And you will see everything in detail when we will just coding. Okay, but for now you need to understand the concept. I know these concepts are new, so if you are just finding difficulty, do not need to worry. Just accept the fact, bro, this is new. I just need to put more focus and I just need to maybe rewatch some parts of the video to understand the concept. And to be honest, when I was learning these things, I was also watching the parts of the videos multiple times, reading some concepts from the books multiple times, reading the documentation multiple times. So you do not need to say, hey, I have to grasp this concept in one go. It's fine. It's fine. Just make those efforts. That's it. Make sense? Do not feel like you're dumb. You're not dumb. You are just like behaving like a dumb. You're not dumb. Okay. So these are the data sets. Now there's one more component which is very important, which is called pipelines. Now what are pipelines? In general, we refer this keyword pipelines to ETL, right? Whenever you just want to create a ETL. Same thing here as well. So let's say within your development, within your notebook, within your, let's say, file, whatever you are using, you want to now run everything. For example, let's say you created the entire flow. You created, let's say, streaming table, and on top of it, let's say you created the mat view, and on top of this, you created another mat view, right? So it will create a kind of DAG. If you just closely observe this, it will create a kind of DAG, right? So do you know what? Within SDP, we have this DAG concept available. That means whatever your objects are will be converted into a DAG. And do we need to build this DAG? No, we just need to write our code. Pipelines within SDP will take care of all the dependencies, all the execution order and everything, and it will create a DAG for us, and obviously it will run it for us. That is the power of SDP. You do not even need to build this DAG. It will be auto created using our code. And yes, you need to specify those things in your code, but that is very simple. Very simple. Do not relate this DAG with Airflow DAG when you need to just define everything. It is a declarative framework. You do not need to define anything. Okay? Make sense? Very good. Very good. Very good. I know you are learning new things and very good. Appreciate yourself. And here is the concept that you can just read if you want. This is the official documentation. Okay, but I'm just teaching you the same thing, so it's fine. You can just focus on the video now, but I'm just giving you the resources as well so that you will feel, okay, we have everything ready with us and we just need to focus. That's it. Okay, you can either read it from this documentation or this documentation, doesn't matter. The thing is, you are learning something new, which is important for your future, and that's it. Because people nowadays are just making a chaos. Hey, will AI take our jobs? Hey, will AI replace data engineers? Bro, first focus on data engineering. First be a good data engineer. Then just worry. Then you can worry about these things. Will take the jobs? If you have the talent, if you have the knowledge, how you can just expect like AI will take your job? How? You do not even need, you do not even know like what data engineer does or what data engineer will do in future, and you are just worrying about will AI take the jobs? Bro, what are you doing, man? What are you doing? You first need to understand what data engineer will do in the future. If you have that clarity in your mind, you will not have this question like will AI take your job or not. You are having these questions right now because you do not even have the clarity in your mind what data engineer will do in the future. You are still you still have that old school picture in the mind. Data engineer will do this much of thing, and data engineer will optimize Spark code. Data engineer will do everything with the Spark submit command, and you have this old school image of data engineer in your mind. Data engineer, not this thing now. No. That's why I always say choose your mentors wisely. Because nowadays what is happening? Data engineering is a popular stream, so everyone now making videos around data engineering because obviously like that is a hot topic. But you need to pick your mentors wisely who have the updated knowledge, who have the updated picture, who have the clarity about the future. Obviously, future is unpredictable. I'm not saying like just make an astrologer as your mentor. No, no. But at least someone who knows about the latest trends, like what's going on in the market. Choose your mentors wisely. That's all I can say. Okay, rest the choice is yours. Whatever you want to do. Obviously, you will do the same thing. What you want to do. Okay, but I know about my data fam. They will listen to me. They will actually think about those things that I'm just trying to say, because I cannot like say everything like openly, but they will get the context that what I'm trying to say right now, because they can understand my feelings very well. Okay, because they are connected with me. Okay, so yeah, that's all. So now enough conceptual knowledge is given. So now let's gain some hands-on. Let's make our hands dirty with those development. Okay, so now you have two options to continue with this particular development. One is you can just set up everything on your machine, okay, using open source, which is Apache Spark. Okay, which is Apache Spark, which is a great thing. I'm not saying like it, which is not doable, but you would need to do a lot of installations. Okay, and you may find a lot of errors just to install the stuff, and that can become a hurdle in your learning journey. And I do not want that. To be honest, I don't want that. I'm not saying like you should not practice or you should not try installing all those stuff in your local machine, but I am saying this, that you need to do all of those things once you know how to run or how to develop Spark Declarative Pipelines. So whenever you're learning something new, I always say this thing, start learning with the resources which will make your installation process minimum, because you do not need to spend that time in your installation processes right now. Make sense? So how we can just work with SDP then? The best solution is Databricks. Why? See, Databricks, now you will say, hey, wait, stop. We do not have any credit card. Hey, we do not have any kind of cloud subscription and we do not need to spend any money. Now just tell us the solution, bro. I already heard you. That is why I'm saying Databricks. Databricks has something called as Databricks Free Edition. And the best thing is, Spark Declarative Pipelines are also available in that free edition. So you do not need to worry about any kind of, you can say, cloud subscription or nothing. You just need to create a free edition account on Databricks. If you have that account, very good. If you do not have that account, I will just show you how you can just create that account. And once you have that account, you can just kickstart your SDP journey like this. If you do not want to go with that way, then you have to follow these steps. Okay, how you can just install Spark, and then how you can just install Spark Declarative Pipelines, and how you can just configure this pipelines projects, and it will take a lot of time. Okay, but currently you are focusing more on the SDP part. Make sense? So that is why let's kickstart our learning journey with Databricks, and then once you learn SDP, then you can just play with it, and you can just see like how we can just configure this SDP in your local machine as well. It's like up to you, because in the industry, obviously you'll be just using a managed version of it, which is Databricks. You will not be just running your own Apache Spark in your local machine. Make sense? And people used to do it before this era, because Databricks was not free at that time, but now it is free. So you should just take advantage of it. So let's try to create a Databricks account. You can simply say Databricks Free Edition. Okay. And you can simply say Databricks Free. And here this is saying get 14-day free trial. This is not actually free. This is just free for 14 days, but we are looking for Databricks Free Edition, which is free after 14 days as well. Okay, so you can click here. Do you want Databricks for personal use? Get the core features free forever with Free Edition. You need to click here. Then you will get the updated link, and this is for Databricks Free Edition. Okay, then you can simply continue with Google or Microsoft, or you can create your new email address as well here, and then continue with the email, and then you will be able to see that Databricks workspace. That's it. You do not even need any kind of cloud account. You do not need anything. You just need yourself. That's it. And learning attitude. That's it. And Ansh Lamba, obviously, because he will tell you how to do it. Make sense? Okay, so quickly create your account and just come back to this video, and we will be just doing a lot of fun. So now I assume that you have created your Databricks Free Edition account. Okay, so let's kickstart our learning journey. What is the data? Where is our data? And where is our nodes? Everything is in the GitHub repo. You can just go and just enjoy. But for now, let me just show you everything. So I will open my Databricks Free Edition. Okay, so let me just open this. So this will open my Databricks account. Okay, and yours should also be the same. And here we have our Databricks free edition account, and welcome to Databricks. And why they didn't feature my video here? Where is Ansh Oh man, just tell them to just feature my video, bro. The person is teaching Databricks since so long and with so much of dedication, and they're not putting my video here. So okay, it's fine. I feel better when you appreciate me more. Okay, so that is my way of having that vibe. So you can just cheer me up in the comment section. Okay, I will feel better. Okay. Okay, I'm just kidding. So this is our Databricks workspace, and by the way, everyone is a great mentor. Not everyone, but yeah, few are very good mentors. So I appreciate that, and well done. Everyone is doing a great job here. Very well done. So now this is our Databricks workspace. Okay, so this is like newly updated. Okay, and this I love this UI. So you can also see this. The most important thing before starting anything, you need to go to your icon. Okay, just go to settings, and here you need to go to developer. Okay, and here are some versions available. These are basically the settings that you need to turn on. Okay, so what you can do here, you need to go down and you need to make sure that all the things are turned on related to Spark Declarative Pipelines or Lakeflow Declarative Pipelines. How you can just see that, just scroll down, you will see something called as see these things, Lakeflow Pipelines Editor, because we'll be just using this feature. I love this feature. This is like newly added to build SDP. This is my personal favorite, and you're gonna love it. Why, bro? You will feel like you're working with your favorite IDE, which is, let's say, for example, VS Code, and amazing experience. I love this. Like, there are two basically options to develop the pipelines. One is notebook and one is Python files. Whenever you are writing PySpark code, notebooks are like great option, but when you're building SDP, I love this feature. Okay, so you need to just enable this and this as well. Both are important, so just make sure those are turned on, and you can just copy my settings as well. So you can just pause the video and just make sure everything is same. Okay, makes sense? Very good. So now this is the home page of our Databricks, and if you are not sure about like what is Databricks, and if you want to master Databricks, bro, let me just give you the best resource out there. Just go to Google or whatever your favorite browser is. Simply search Databricks full course Ansh Lamba. And just a pro tip, if you just want to learn anything in the world of data engineering or AI data engineering, just search the topic in the YouTube and add Ansh Lamba as the keyword. You will find the best resource, and you can just validate it in the comment section. Okay, so you can just read the comments if you just want to validate anything. So this is the video, modern Databricks with Unity catalog. You can just watch either this video or this video. Both are amazing. If you want to become a pro, I would say watch both the videos. If you just want to watch one video, because I know you're really busy, blah blah blah, so just watch this video, because this is the modern Databricks in which you will learn everything that revolves around Databricks right now. So just go and master Databricks with these two resources, and obviously both are available on YouTube for free, and you're gonna enjoy and you're gonna learn a lot of things, like a lot of things. Okay, makes sense? Very well done. By the way, I have created the roadmap as well, where I have put all the resources for becoming data engineer from scratch. You can just find the repository in the description as well. So that is also available for free, because everything is on YouTube. Everything is on available on YouTube, and you can just enjoy. Make sense? Okay, very good. So this is our Databricks, and let me just give you a quick overview, very quick 2 minutes overview. So this is the area where you will see all the options available that you need to do as a developer, or you can say that you need to use as a developer. So first of all, this is home page. Okay, then we have workspace. So here you will find all the workspace, and I have created some workspaces. That is why you are seeing many workspaces here. So you can just ignore, because we do not have any workspace in the new you can say instance, so that is fine. Then we have recent tab. Recent tab is nothing but when you just open something. When you just open something, right? So it will be like come in recents. Catalog will be having all the catalogs that you create, like all the you can say databases, all the schemas, all the catalogs, whatever. Then here we have jobs and pipelines, where we will be creating so many jobs, so many pipelines. Okay, not jobs, but yeah, pipelines. Then we have compute, where we can just see all the computes available if we have any kind of SQL compute available. And then in the free version, we do not have all the features available, but we have everything that we need to use to learn. Okay, then we have marketplace. Marketplace is a kind of place where you can just use third-party services. Oh, this is very similar to Azure Marketplace where you find third-party tools. Similarly, Databricks has also created this marketplace where you can just use the third-party tools. For example, Fivetran, for example, DBT, right? So you have all the things here. What is this? Data transformation copilot, blah, 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 blah. I love DBT. Okay, I love DBT. I'm a big fan of DBT. Fivetran is also very good. So you can also see that. Do you need a complete tutorial on Fivetran? Because Fivetran is an amazing thing in the modern data engineering world where you can just connect data. So I can just think about it. Just do let me know in the comment section. And there are so many other services. Okay. Then this is the area where you just write your SQL code or you just do all the warehousing, all the stuff here in the SQL tab. You can just see it here. Okay. Then you have data engineering tab as well. In data engineering, you have job runs and data ingestion. Okay. This is like more related to troubleshoot something related to data engineering jobs, or let's say ETL jobs or integration jobs, everything related to that. But from my perspective, I think everything listed here is data engineers area, because data engineers are everywhere, bro. So now AI and ML, obviously, slowly data engineers also need to learn AI stuff, ML stuff as well, because it is no longer now a kind of different domain. No, it was few years back, but now it is the part of data engineering. So this is like very quick overview, and obviously this is like UI is pretty straightforward. You can just click here and there and you will learn a lot of stuff, and you are good to do that. Do not need to worry. But in this particular video, the focus is on SDP. That's it. We are simply using Databricks to run our SDP. That is it. Because for Databricks, we have dedicated video available, dedicated resources available to master. But in this video, only SDP. Very good. So we're gonna start with simply creating a catalog, because whatever we'll be doing, we need to use a source, right? We need to use a source. So what I will do, I will go to catalog, and you can also go to catalog, and you can click here on the plus sign. And now let's create a new catalog. Click on create a catalog, and I will simply say SDP catalog. Make sense? SDP catalog. Okay, use default storage, yes, and then click on create. So what it will do, it will create a catalog for us, and you can simply say configure catalog and simply say next and then save. So our catalog is created. Now what is a catalog? In layman terms, you can treat catalog similar to database. Simple. Okay, simple. Okay, because in Databricks we call it as catalog, but in some other technologies you will hear it as a database, so it's fine. Okay, cool. And within the catalog, we have some schema. We have default and we have information schema. Let's create our new schema, and we will call it as, let's say, create a schema. Where is schema? Oh, here, create schema. I will simply say source. Okay, source. Click on create. Very good. So within the source schema, we have nothing because we have not created anything. Okay, makes sense. So what we're gonna do, we're gonna create something. Make sense? Okay, good. We're gonna create something. So now let's create something within the schema. So how we can just create something? Obviously, we would need a SQL script, or we would need a notebook. Depends like what compute we want to use. Okay. So let's try to use normal notebook, because that is your style of writing as well, right? Okay. So let's try to go to workspace, and let's create a new workspace. Go to workspaces, and actually go to home. It's fine. Okay. So what I'm going to do, I will simply go to home. You can also go to home. Okay. And you can click on create, and just click create a folder. Now what we are trying to do, we are simply trying to create a folder for our video, because we will simply storing all the resources within this. I will say SDP tutorial. Make sense? By the way, again, I'm repeating, all the source code, all the notebooks, all the files, all the notes, everything will be available in the GitHub repo. But you are my data fam, and you love me so much. I know I love you so much. One promise I need, you will be writing all the code as well on your own. Yes, if you feel stuck, then only you will be going to the resources. Okay. And then you can just refer the code, but you need to practice on your own. Okay. Promise, pinky promise. I am wearing the pink hoodie, by the way. So pinky promise. Okay. From here. So yes, let's try to write everything. So within this particular folder, let's try to create a notebook. Okay. And I will name this notebook. And again, you will see this UI if you have enabled that thing that I told you just few minutes back. Okay. Remember? So just make sure it is turned on. Otherwise you will not see this UI. Okay. So let's have some space here and let's rename it. I will simply say source prep. Source prep. Okay. So now you will say Ansh Lamba, you forgot to create a cluster. And do you know what? In Databricks, you first need to create a cluster, bro. Go and create a cluster. Oh, okay. Okay. Good, good, good. By the way, you do not need to create a cluster in Databricks now. Why? Because Databricks provides you a default cluster called serverless compute. Oh, yes. Just click on connect and you will find that cluster here, serverless. So it is already there for you. You do not need to worry about things. You do not need to worry, hey, what will be the node size? What will be the VM size? How many cores will be there? Nothing. Serverless compute and that's it. It will be auto scaling. It will be doing all the things behind the scenes, everything for you. So see, Databricks nowadays, slowly, every day, taking care of all the boilerplate things that you used to manage. Very well done, Databricks. Very well done. So let's try to create our table. So I'll simply say, let's try to see the catalog. Click here. And if I see SDP catalog, we have this schema. So we have this thing. Okay. So I'll simply say create table. Okay. Create table and let's say sales. Create table sales. And let's define order ID, product ID, revenue, and date, and then store ID. Yeah, that's it. Okay. Because this is just a demo table that we are creating. And let's say insert into, okay, insert into sales value. And I think I also need to say catalog. Catalog is SDP catalog dot source dot sales, because we need to register the table under this catalog, right? So let's do the same stuff here. Source sales. Perfect. Now let's try to fill some values. 100, this thing. Okay, perfect. So this particular AI assistant is helping me to fill this data. Thank you so much. Thank you so much. Okay. Okay. Perfect. Perfect. So let's try to insert this. Let's try to fill few more records. Okay. Perfect. So it's fine. Okay. So let me just run this. And you should know like how to run this. Just hit Shift plus Enter if you do not know. Okay. So this is our table and it is inserting some values in this table. Make sense? Okay. So it will take some time to run our first code cell because it warms up the machine and it takes a little bit of time. And after that, it will be like very, very quick. And once it is done, I will query the data just to see like how does it look like. Select asterisk from SDP catalog source.sales. Okay. Let's try to see the data. So currently it is running. Okay. Let me run this. And I can see the 4 rows. Perfect. Now I have this thing ready. Okay. So our source is ready, by the way. Congratulations. Now we can just use this source to start working with SDP. Right. So now what we're going to do, we're going to go to home. Okay. And Databricks, listen to me, bro. Put my video here as soon as possible. Okay. Because I love Databricks and I know Databricks loves me. So let's take this love forward. Okay. So now, just kidding. Now what we're going to do, we will simply go to jobs and pipelines. Okay. Click here and you can just ignore these things and let me just delete it. Otherwise you will say, Ansh Lamba, you created jobs. I cannot delete these because I deployed this using asset bundles. I was just doing some fun stuff. So you can just ignore this. Okay. So now if we just want to create a pipeline, you will say, Ansh Lamba, we do not want to create a pipeline. We want to create a Spark Declarative Pipeline. My bro, that is also a pipeline, right? So just click on create and click on ETL pipeline. Okay. ETL pipeline means Spark Declarative Pipeline. Okay, makes sense. Good. Click here and you will see this UI. You will see this UI only and only if you have enabled that thing that I mentioned few minutes back. Okay. Otherwise you will not see this. Okay. Just click here on the settings and just click on developer. Okay. Makes sense. On developer and just enable this. Very good. So now this is the configuration page. Okay. Now what is this page? What is this page? Let me just tell you. If you use Apache Spark to build the Spark declarative pipelines, then if you just go here, you will see this thing, pipeline projects. If you use Apache Spark open source in your machine, if you want to manage everything on your own, then you would need to create this pipeline projects file. It is a kind of YAML file. And by the way, bro, after AI, YAML's popularity is like skyrocketing, man. Like obviously it was very popular thing in CI/CD, but now I am seeing every new, you can say, development is using YAML under the hood. Wow. YAML is amazing. I love YAML. Better than JSON. And yeah. So it is creating this pipeline projects, right? So this is the kind of similar thing that Databricks is trying to do using UI so that you do not need to create this file. But I'm so sure under the hood, they are just doing the same stuff. Make sense? This is like basic configuration. Okay, so let's try to give a name to our pipeline. I will simply say first SDP pipeline. Okay, now this is very important. We need to pick a, you can say, catalog. Okay, so I'll simply say workspace. And here, I will say, let's pick the catalog as SDP catalog. Okay. Schema. Do we have any kind of schema? Yes, we do have source schema, but obviously we do not want to write the, you can say, result into the same schema. Let's create a new schema and you can even just write here as well. So let's say I want to say sync or let's say target. I don't have that. Okay. But I can create on fly. I'll simply say target. Makes sense? Click on create. So this is the basic configuration that I have picked. Now I have few options available to start my project. I can either start my project in SQL or Python. I will prefer you start your code with Python. Why? See, obviously it is your choice. Obviously both are same, both are easy, but most of the people prefer writing the code in PySpark instead of Spark SQL. I'm not saying like people do not write the code in Spark SQL, but the first choice of a traditional developer, PySpark or big data developer is PySpark. So when you use SDP with Python, you will get the same vibe. You will feel like you are using PySpark. You can pick this thing. This is my personal recommendation to those who want to feel like the same. But if you want to, if you are coming from a SQL background, if let's say you are coming from a Snowflake background and you just want to switch to Databricks, then obviously you'll be more comfortable with SQL. You can pick this thing. Choice is yours. Okay. But for this particular tutorial, I will just using more of Python code, okay, PySpark code, but I will also show you some basic basic thing with SQL so that you can just kickstart your SQL coding as well. It's same, bro, same. 99% of the things are same. Do not feel like, oh, we want to use Spark SQL, bro, listen, both are same, okay? Do not behave like that dumb guy, okay? So let's click here and it will start our project with the Python code. Okay, so this is our UI and this is my personal favorite. Let me just explain this thing. First of all, click on this 3 bars because we do not want this space. So this is basically the project that we, or you can say this is the IDE for our pipelines for SDP. Okay. First thing first. Okay. What is that thing? What is that thing? So basically you first need to change the location of this project. What do I mean? And it is very important and it is very, you can say, error prone as well. So what happens whenever we just create a kind of project, it creates a bundle, not bundle. You will be confused like what is asset bundle? It is not like asset bundle. It's create a kind of group. It creates a kind of folder. It creates a kind of repository. Make sense? Like where you have so much of things. If you just observe the left hand side, you will see first SDB pipeline, which is our pipeline name. But we have exploration folder, we have transformations folder, we have utilities folder. Like, what are these things? What are these things? So bro, what usually happens, this is a kind of package. I think package is the right word. This is a kind of package that we get. So now this particular thing, explorations, this is the area where you can just do your rough work. What do I mean by rough work? Whatever you will do in this folder will not be the part of your project. Okay, will not be the part of your project. Okay, so let's say you want to do some analysis, quick analysis, blah, 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 but you do not want to make that analysis as the part of your project. You can literally save anything here and it will not become the part of your development. That's a very good thing. Yes. Then if I talk about this area, this is the main area of your code. What does it mean? Whatever you put here under the transformations folder will be executed, will be used to create the pipeline. How do I know? How do I know? So obviously through the documentation, but you can also get to know this. You will see a small pipeline logo, which is here as well in the main pipeline and in the transformations folder. This is a kind of identity that you can also use to identify it. Ansh, Lamba, yes. Can I change this folder name? Will it impact anything? You can change it, but you also need to change the stuff from here, not from the background. What do I mean? If you are in this editor, whatever changes you are making will be automatically synced. But let's say you are going to the location where these folders are stored. Obviously it is stored under your workspace, and you make some changes there. It will not be auto synced and it can break your code base, which is not a good practice. And it is also written in the official documentation that whatever you want to do with your code base, always do it from the editor using this user interface. Makes sense? And this thing, utilities, as the name suggests, let's say you are using some Python classes within your code and you can just save everything here and you can easily import it. How? Like just using from this, and you will be easily able to do that thing. Makes sense? Makes sense? Because it is very easy to import anything from the folder. Yes, you would need to make sure that how you are importing the utilities. For example, let's say you want to import anything. So you would need to go one step above, and then you will be just importing this thing using utilities. Make sense? Okay, very good. I will just show you, don't worry, everything I will just show you. So these are this is basically the code base that you can just use. Okay, very good. Make sense? Okay, very good. Now you need to click on these three dots and you need to say move root folder. What does it mean? So let me just show you where currently this folder is residing. So whenever we just create any kind of SDB pipeline, it gets stored in your default account. So if you just go to settings, you will see the location here, or you can just click on UI, or you can also see the YAML, but it is also written here in the code assets root folder. If you hover over this, you will see that it is saved in my account, workspace, users, and then my email ID, and then directly this folder. But where is our project? Where is our project? Our project is not here. Our project is within the tutorial, SDB tutorial. So you need to move this. So now if you move this folder manually by going to that location, it will not be automatically synced. You have to update this code as well, and that is very error prone. So that is why whenever you want to move your root folder, you have to do it like this. First thing is this. Second thing, this is your answer of the question when you said, hey bro, can I just rename this folder? Yes. If you just rename this folder, let's say I rename this folder like this. I just call it as, let's say, transformations Ansh. If I say okay, you will see that it will be automatically synced. Now this is the source code. Why it is source code? Because everything which is listed inside this will be my source code for pipeline. Make sense? So it is automatically synced here. Wow. Because I change it from the UI, not automatically by going to that location. Make sense? Let me just rename it because this is not a good name. Rename transformations is fine. Makes sense? But by default, transformation will be a folder where you will save all the code. And let me just move this source code and I will say move root folder. And then I can just pick the location where I want to move it. I want to move it inside SDP tutorial. Let's move it here because this is our folder. Make sense? Very good. Now if you will see the settings, now you will see that it is inside the SDP tutorial. So always move the root folders from this UI. Okay, very good. So you have understood everything. Okay, very good. This is the code base structure that you have because this is basically the fundamental thing, but it is very important. And this is the area where you will see all the DAGs. Okay, whatever you will be building, everything will be listed here so that you can just visually see what is going on in your pipeline. Make sense? Like the interface so far? Because I love this. Okay. And you can also make it as like a dark theme. And for SDP, I love the dark theme. Those glowy edges of dark theme. Oh man, of this DAG. Next level. I love this particular area because you will see glowy edges when you will building DAG. Oh man, let me just switch it to that thing. Go to settings and go to developer and dark mode. Yes, perfect. I am not a very big fan of dark mode for notebooks, but I'm a very big fan for dark mode for this Lakeflow editor, and I love it because you get the VS Code vibe and amazing. So this is the thing. Okay. And here when you will see the DAGs, it will be like with glowy edges and you're gonna love it. Okay. For now, let me just click here to have the space available here to write our code. Make sense? Okay, perfect. Let me just increase the size of the screen. Yeah, perfect. So now, oh, by the way, this ring is also matching with the color. Nice. Okay. So now we are all set to see what we're gonna do. So first of all, you need to know how you can import the pipeline package. Okay, it's very simple. And even before doing that, I can just show you the demo pipelines that we have got from the Databricks. If you see it, first SDP pipeline, you will see some code written here just to give you some demo code that you can just see from PySpark, import pipelines as DP. DP means declarative pipelines. Okay. Then from PySpark.sql.functions, whatever. Okay. And from utilities, import utils. What is this? Utilities, import utils. So here, if you have anything, you can import it here. And they are assuming that everything that you have is within utils.py. Now a good developer will ask this question, anshlambacollab, a quick question. How we are able to import this folder directly because we have not added this path in the system path. So whenever we build any kind of SDP within Databricks, they automatically attach this path into the system path so that you can easily import your utilities. So see, if you have some utilities available within your code, within your development, you can write it in the utils.py file, or you can create your own file and you can just mention it here and you can just import the utilities folder directly. That is the power of this IDE. Otherwise you would need to do it everything manually, which is not a very good practice. Okay. So see, if I have utils.py, so what this is doing, this is just a kind of function that we are creating at the rate UDF, and we are simply creating a UDF for this, and you can literally do anything with this particular thing. Okay. And we are creating this user defined function and we are using it here. Makes sense. Okay. And do not need to worry, we will be just creating our own stuff. So just ignore these two things. Okay. So let's try to create our own file. Okay. I will not remove these two files for now. Let's keep it there, but we will remove it after some time. So let's create our new file. So let's say create file and it will be a Python file. So I'll simply say first dag.py. So this is an empty Python file, and let me close the other ones. So within this Python file, we do not have anything. So the first thing we're going to do is import. So we'll simply say from PySpark. Okay. From PySpark, import pipelines as DP. You can also say it as SDP because till yesterday, okay, in the documentation, it was like they were just importing as Spark Declarative Pipelines as SDP. Like I can just show you in the code, like as SDP, but today they have just made it DP. I personally like DP because it also gets aligned with the Databricks documentation. So you can just also import it as like DP, but choice is yours. Okay. It's same thing. Like you always import pandas as PD, but you can use any keyword. You can also say PAD, but it doesn't make any sense, right? So from PySpark, import pipelines as DP, and I can also import some stuff. Let's say from PySpark dot SQL dot functions, import asterisk. Okay, that's fine. So now what we're gonna do, we're gonna create our first object, basically first flow. Okay, and this flow will create a materialized view. What? Materialized view. So let me just write it for you. Materialized view. Now what is a materialized view? Let's try to learn that in detail. Okay, materialized view. Materialized view is very interesting, by the way, and a little bit confusing, but do not worry, I'm here to remove all the confusions. Okay, makes sense. Now let me take you to the official documentation. Okay, and let me just go to develop pipelines and then materialized views. Okay, let's go to overview. So now what are materialized views? Let's try to read this first of all. Like standard views, materialized views are the results of a query, and we know that, and you can access them the same way you would a table. Unlike standard views, which recompute results on every query, materialized views cache the results. Okay, these are the fundamentals of SQL. This is not like something very new that you are just learning with SDP. This is like fundamental thing, right? So they also cache the results and refresh them on a special interval. Make sense? This is a very basic understanding of materialized view. Because materialized view is pre-computed, queries against it can run much faster than against regular views. So that is why materialized views are becoming the first choice over the views, because they cache the data as well. And if the data is not changed, they will get the results very, very quicker. Make sense? But now let's talk about in the declarative framework, in the declarative pipeline. Materialized view is a declarative pipeline object. It includes a query, obviously, and a flow to update it and cache the results for fast access. Now a materialized view tracks changes in upstream data. That means it will be tracking changes in our source. Okay, and this is the important thing. On trigger, when you'll be just triggering it, it will incrementally process the changed data only. Wow. And apply the necessary transformations. So it will incrementally process the data instead of processing all the data. This is the game changing thing. Make sense? So in short, materialized views are your incremental batch processing objects. Incremental batch processing objects. Incremental automatically. That is a good thing. How materialized views work, we will just talk about it, don't worry at all. And here are some common code examples. You do not need to worry about that. Now it's time to talk about this thing. Ansh Lamba, nothing happens automatically. Okay, we need to write the code. Like obviously if we are not writing the code, someone else is writing the code. So how it is tracking everything incrementally? Because in batch processing, we do not get the incremental behavior naturally. We all know this. So what is the magic behind it? Let me just tell you. So when the pipeline defining a materialized view is triggered, the view is automatically kept up to date. Often incrementally, this is the word. So this is not a guarantee that it will all the time give you the incremental data. Okay. Databricks attempts to process only the data that must be processed. That means the new data. Materialized views always shows the correct result. What does it mean? Because it will just try to process the data incrementally, but if it feels like let's not process the data incrementally, let's process all the data, it will do it. It will not compromise on that thing. That is why it is saying often incrementally, not every time. Okay. So as I just said, even if it requires fully recomputing the query results from scratch, it will do it. It will do it. So why it cannot give us that incremental data every time? Because this is a batch data. Okay. So what it will do behind the scenes, it will compare the cost. Sometimes processing the data incrementally can give you some flaws or can be more computationally expensive. Yes, it can happen. So in those scenarios, it will recompute all the data every time. Not every time, like in the scenarios where it will feel that it is expensive than processing the incremental data. So it is the best combination of both the things. And you do not need to decide whether it will do a full refresh or just incremental refresh. It will do on its own. Wow. This is literally wow, man. Makes sense? So since updates create correct queries, some changes to inputs will require a full recomputation sometimes, not every time. Okay. They are not designed for low latency use cases. That means it is not designed for streaming, real streaming. It is just designed for incremental batch processing. Make sense? Okay. Not all computation can be incrementally computed, as I just mentioned. Make sense? Very good. Now they have a dedicated page as well for incremental refresh for materialized views. And this is the detailed version of exactly what we have said and discussed here. And with obviously some more technical details, if you just want to gain those details as well with some examples, you can just go and read it. But if you just understood the concept, it's fine. It's fine. Okay. And obviously there are some things listed here which can just optimize the materialized view, something called as deletion vectors, row tracking, CDF, that is change data feed. This is like more on the Delta Lake side that you can just use. But if we are just focusing more on SDP, you can ignore this for now. And after that, you can just read it. Okay. Very good. Very, very, very good. Makes sense. And we have like dedicated support for full refresh as well. So whenever you just want to fully refresh your tables, materialized views, you can do that as well. Make sense? Very good, bro. Very good. And as you can see, let me just show you. Come here. You were saying like whether we should use Python or SQL. Let me just show you the difference. See, this is the Python code, which is more inclined towards PySpark. Okay. And I know my data frame is like fully on the PySpark side. I know that. Okay. I'm not saying like Spark SQL is not very, very good, but PySpark is like that old school vibe, right? That old school vibe. So now if you see the SQL code, it is not a very, very like difficult thing to understand. But if you understand this thing, you can easily write this code as well. What they are doing, create or replace materialized view and then query. That's it. That's it. But this is more Pythonic. This is SQL. Choice is yours. But we are like old school PySpark developers, so we're gonna love this. Okay. Again, it's like very easy. So you can switch anytime between these two. When I started learning about this thing, and at that time it was called as like Delta Live table. But yeah, it is not exactly same. The core idea is same, but there are so many changes. There are so many upgrades in the API, syntaxes, decorators. So that is why it is not exactly same now if I compare it like with the previous version. But yes, the core idea is same. Okay, so I started with Python. Okay, and I was like, okay, this is cool because I was like, we will just try using SQL as well. But yeah, let's start with Python. So let's try to write our first code for materialized view. So what I'm gonna do, we first of all define a function. I will simply say def. Okay, and I will say, let's say sales. Okay, and I can also say, let's say source sales. Okay, just a Python function, nothing special. And I can use that particular thing that we use, like braces. Okay, then hit enter, and then I can, within this function, I can write my code. So what I'm gonna do in this function, I will simply say df, which is a data frame, spark.read.format. Okay, or let's say format is delta, or you can also say read.spark.read.table, because we have a table, dedicated table for it. And you can simply say, what was the catalog name? I think the catalog name was SDP catalog. Then within that we have source. Okay, and then we have sales. Make sense? So this is our, you can say, table that we want to read. For this materialized view, we do not want to perform any transformations, but you can just perform, let's say df equals df.filter, whatever, but we do not want to do this. Okay. Or just for your sake of understanding, let's do one transformation quickly. Let's convert our date column into the date in the date format. Okay. So let's do this date, month, dd, yy. That's it. And we will just returning df. That is it. That's all we are just doing right now with this function. Now, do you know what? this function will perform or basically this function will create a materialized view. Really? Yes, but you need to use one decorator. It is called @dp because you imported the pipelines as dp. I will say dp dot materialized view. This is the decorator that it uses to convert your function, basically whatever you're doing inside the function, into the materialized view. Remember the flow. Flow says read the data, okay, and then transformation, and then output. So we read the data, very good. We applied transformations, very good. Now what is the output? The output is a materialized table, materialized view or table, whatever you want to say, materialized view. So output is a materialized view. How does it know? Because we use this decorator called dp.materialized view. This is a new decorator, by the way, okay? So we mentioned this thing. This is the differentiator. How it will know that we want to create a materialized view using this decorator. Make sense? So this is the output of this flow. Flow is a materialized view. Like output of flow is materialized view. Now a few of you will say, like, what is a decorator? Basically, this is a Python concept, okay? Fundamentals of Python. Decorator is nothing but takes your function and decorates it. Takes your function and decorates it. That's it. Wow. Literally wow. So it will take my function, this function, and it will decorate it. And what it will do in the decoration step, it will simply create a materialized view. Ansh Lamba. Oh, Ansh Lamba. Yes. What is the table name? Like, what is the materialized view name? You didn't define the materialized view name. Okay, very good question. So when you do not define any name, it will simply pick this function name as your materialized view name. So my materialized view name will be source_sales. Wow. And what if you want to define the new name? See, personal recommendation, you should not define a new name because it will be very hectic if you have a long code. You will be just finding difficulty in debugging because your table name will be something else, function name will be something else, but you have the liberty to do that as well. So you can simply say name equals, let's say, source sales, and you can just give any new name if you want. I'm just giving the same name, but yeah, you can just do it like this. Make sense? So this is my code. Let's save it. Okay. And now I want to see the DAG of it. Just this. I want to see the DAG of it. So how I can just see the DAG of it? I can simply click on this drop down and I can say dry run. What is dry run? Dry run is the concept which will check your syntax, which will check your code. If it is like running fine, if there are any errors, it will highlight that. But otherwise, if everything is fine, it will simply throw the DAG that this is the DAG. And if you are satisfied with your DAG, then you can simply run it. Otherwise, dry run means you are not actually running the code, but you are simply checking the code like if it is fine or not. Okay, and you can see like it is running this. And all the DAG related visualization will be here. Click here and currently see it is just building this DAG. And it will take some time to build that. If there will be any error, you will see it here. Wow, there's an error. Okay, what is the error? So it is saying the table or view SDP catalog dot sources dot sales cannot be found. Wow. Verify the spelling and correctness. So we do have, I think, a catalog called SDP catalog, and then we have sources or source. Maybe sources is not there, maybe source is there. I'm not sure. I can just check quickly. If I go to catalog, if I go to SDP catalog, yeah, we have source, not sources. So see, that's how you will see the error. Now I have fixed the error. Let's click on dry run and let's see if it is fine. Makes sense? I love this glowy visualization. This is so cool, man. So cool. Because see, when you get this experience, you do not need to go to those VS Code and all, because see, like you are getting the same experience here. Why you want to switch to VS Code, right? So I love Databricks for that. They just make our, like they just actually do the stuff for developers. Other companies are just building the stuff for, let's say, managers, for directors, which will make the life easier for them. They do not need to hire more developers. But obviously, Databricks is trying to help the developers as well, that they will get the better experience. That is why I love Databricks. So they do care about us as well. So love you, Databricks. So now, see, we have a DAG. Ansh Lamba, what is this? Wait, hold on. What actually happened? Let me open my code base as well. Ansh Lamba, what is this? And what? Okay. This is fine. This is our materialized view. What is this thing? What actually happened? I was in the same shoes. Okay. Don't worry. Before, when I was learning these things. So what actually happened? How many files do we have here in the transformations folder? 3. Okay. 3. Good. Do you know what? Whatever Python files we have under transformations folder will be evaluated, will be used to build a pipeline. That is why I didn't delete these 2 files, because I wanted to show you this. So for these 2 files, this materialized view is the first step and second materialized view is the second step, and it is dependent on the first one. Okay. And how did it find this? Even if both the files are different, that is a power. Because in the code, they are specifying it. Specifying it. Okay. Now, this third file is not using anything from this. So it is an independent activity. See, I am using my source directly from the table. I'm not using any kind of object, right? So that is why this is an independent activity. But this is a part of the same file. Basically not the same file. This is the part of the same pipeline. See, the pipeline name is this. So that means you can run multiple flows within one pipeline. Wow, this is so cool, man. Because see, whenever you're just building the pipeline in the real world, you just create so many flows. So you can actually build so many flows within the single pipeline, dependent or independent. Wow, man, this is so powerful. Yes. So this is our materialized view that we just want to do that. And I can just ignore these 2 flows. Let me just show you how. I can go to this file and I can comment it out everything. So I will comment it out and I will comment out this file as well. Perfect. So now if I'll be just running my DAG again, you won't see this. So let's see. So it is preparing a new DAG for us. So this time it will again evaluate everything. It will evaluate all the 3 files, but these 2 files are now commented out. So there's no code behind these 2 files. There's only one file, which is called firstdag.py. That's it. See, very good. Now let's try to see the dependency. How in the previous example, we were able to see the dependency of the same object, of the same pipeline. Bro, this is really powerful if you're just getting my point. See, let me just find that, if I can just find that in the documentation. Let's see the Apache Spark. Yeah, loading data from the, not this. Querying tables, define loops. What was that thing, man? Okay, let me just go in the index. Creating streaming table. Okay, creating data from streaming source. Querying tables defined. Oh yeah, I think yes. So querying tables defined in your pipeline. What does it mean? Let me show you. I created this materialized view. Yes. Now I want to create another materialized view, and I want that materialized view to use this as a source. How can we do that? So I know it's cool, it's amazing, and it's very easy now. Earlier we used to write something called as live keyword, which is outdated now. We do not need to use live keyword in order to refer to the objects created within the pipeline. We can simply refer to the objects using this particular name. Okay. Ansh Lamba, quick question. Can I ask this question? That question? Yes. Ask that question. So basically, let me just show you. Let's say materialized view And don't worry, I will just give you this notebook as well, basically this file as well, referring to another materialized view. Okay. So I'll simply say dp dot materialized view and name equals, let's say, enriched sales. Okay. Enriched sales. Enriched sales means the silver layer. Make sense? Okay. Within this, I want to do some cleaning. Let's do some cleaning. So I will simply say ENR sales, and then I will simply say df. Now this is the thing. Spark dot read dot table. Spark dot read dot table. Okay. Okay. Now you just need to mention source sales, and that's it. That's it. Wow. Wow. Makes sense. Makes sense. If you see the code as well, you will realize that we can literally read it like this. Let's say this is the materialized view, okay, which is referring to this materialized view. Okay. So how it is reading? Spark dot table. That's it. That's it. You can also say spark.read.table or spark.table. It's fine. Both are fine. Okay. So you can simply refer to the same thing using just the name, order's name, and that's it. Wow. What it is doing behind the scenes. So when you simply write source sales, it is behind the scenes writing like this. SDP catalog dot target. Why target? Because the schema of current pipeline is target. But you do not need to mention this thing because it is obvious that if you just using the default configurations, it is SDP catalog and target. So that is why it is very important to define this thing here. Otherwise it will throw errors. So you can simply say source sales, and that's it. That's it. You do not need to worry about anything. Make sense? So this is enriched sales. Okay. Now within this, let's say I want to create a revenue. Okay. Let's say this is our revenue and we will simply return the DF. So we have created a new column within this, which is called revenue. Okay. And revenue is revenue into 1.05. We simply modified this column, a basic transformation, right? We enriched this. Make sense? Okay. Now let's create another materialized view, which will be used as a curated materialized view. Okay. So what it will do, sales, enriched sales aggregated, or let's say curated sales. Curated sales means gold layer where we are simply aggregating the data. Okay. So I'll simply say curated sales and then aggregated. So what this will do, let's try to create a data frame first of all, enriched sales. And here we will simply creating something called as aggregated. So how we can just perform aggregation. So let's say df.group by. Okay. And let's try to perform group by on date. Okay. And then we can simply say aggregated of sum, and we can simply say total revenue. Simple basic PySpark transformation. That's it. Nothing else. That's why I picked Python approach, because you would be familiar with PySpark code, right? And let's say return df. So now what will happen? It will create a tag because see, now you can know that we have three materialized views. View number one, which is built on top of, oh wow, which is built on top of source. Then we have another materialized view, which is built on top of one, right? So it is referring to this. And how does it know? Using this, because it is so obvious that we are reading the same table that we have just created, right? And then we are creating third materialized view using second. So now SDP is smart enough to create a DAG for this using this dependency. And if I just say try run, you will see this tag. Really? Yes, you will see this tag. Okay, let's see. So currently it is creating this, preparing the new graph. So see, we have three objects. I hope you can see this. See, we have source sales, then we have enriched sales, then we have curated sales. And it created this DAG automatically. We didn't create this DAG. It created this using our description. Not description, a kind of, you can say, code that we have simply created. Makes sense. Okay. Now, let's say let's do some modifications because this will give us some more exposure to the other data sets. You will say, Ansh Lamba, let's do one change. Let's create a view, normal view instead of materialized view in the middle. Let's say we do not want to store this information in the middle. We directly want to store, or let's say we directly want to create a view for this like normal temporary view, because we do not want to store any information in the for the bronze layer, for the raw layer. We just want to create views for this and this, like normal tables, but we do not want to store or basically keep the data in the lake for this. So let's try to switch this to the normal view. How we can just do that? So if you just want to create a normal view, okay, then you have a decorator called temporary view. Instead of materialized view, you will simply say temporary view. And let me just try to show you here as well. So streaming tables, materialized views, but where are temporary views? Let me just find it here. Temporary view, yeah, see. So here we have this decorator called dp.temporary view. So when you define this, you can simply create a temporary view. This will not hold your data. This will only hold the query. Make sense? This will only and only hold the query. Make sense? Make sense? Make sense? Very good. It will only and only hold the query. And let's try to create a temporary view in the middle because I want to explain you some stuff. So let's create a temporary view for this. Okay, temporary view. If I simply now click on dry run, there will be a small change in the DAG because this materialized view will be called as temporary view now, and that's it. And then I will just show you the pipeline. Like I will run the pipeline and you will see the difference. Okay, what is wrong? Materialized view. Oh, materialized view. So we need to also remove a view and from here as well. Okay, let's say dry run. So let's wait. Perfect. So now you are seeing materialized view in the beginning, then view in the middle, and then materialized view again. Make sense? So what this view will do, this view will just create a view on top of this materialized view, which is actually a managed table. Okay. And then it will recompute everything from this for this table, and then it can create a materialized view as well. So that's how you can create a materialized view, and then on top of it you can create a view, and then on top of you can just create a materialized view. Make sense? So now we were just running our pipeline as a dry run, but I want to show you and I want to run this pipeline as a normal run. So what I'm gonna do, I will simply change this to the previous state as materialized view. Okay. And now what I'm going to do, I will simply say run pipeline because I want to show you how it will run everything. So now it will run the real pipeline. It is not a dry run now. It will also create a table, and you will see all the three tables, which are called source sales and then on-range sales and curated sales. All the three tables will be there. All the three tables. See, it has started running. Okay. We have 4 records. Very good. It has 4 records. Very good. And it has 4 records. Perfect. So see, this has brought 4 records from the source because there were only 4 records. And then in the materialized view, it just cleaned 4 records, and the curated view, it grouped together 4 records. Make sense? And you can also see the tables here. If I go to catalog and if I go to SDP catalog in the target, you will see the 3 tables. Source sales, enriched sales, and curated sales. All the 3 tables are there. And we didn't create these tables. We simply define our function, declarative framework, and SDP created all of the things for us. Thanks to SDP. Now let's try to see like how it is just processing the data incrementally. Okay, let's add some data in the source. So let me just duplicate this tab so that I can just make the changes in parallel. And I will simply go to recents and I can open the, where is the notebook? Let's go to workspace and then SDP tutorial and then source prep. So let's try to insert 1 to 2 more records in the table. Okay. And let's comment it out. And let's say 5 and then 6. Okay. Let's just comment it out this as well. Perfect. And let's only run this cell. So what it will do, it will insert 2 records in the source, which is called sales. Let's say we got 2 more sales. Okay. So we have those 2 transactions in our source. So let's see who is texting me. Who is texting me? Okay. So we are simply inserting 2 transactions in the source. Okay. Perfect. It is done. Almost. Okay, let me quickly query the data. So we have 2 more records, right? See, 5 and 6. Now let's try to rerun our pipeline. Let's see what happens. Okay. So I have triggered the pipeline again. Okay. So now it is running this. And let's see output records. Incremental. See? Wow. Output record 6. But it is incremental. This is also incremental. So now what it is doing? It is outputting record 6 and now it is outputting record 6. What actually happened? Let me just explain you. So let's wait for it to complete it. So now this is a materialized view, right? It is a materialized view. That means it is a kind of batch table which can process the data incrementally. Okay. Which can process the data incrementally. But just tell me one thing. If this is the source, and this source is being used by the other table or anything, any other object, you need to get all the records, right? If I'm simply saying, hey, I want all the records, select asterisks from blah, 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 blah. I am saying that I want all the records. Makes sense, obviously. So yes, it will output all the records, but it will not process all the records. It will only process only and only 2 records. As you can see, incremental. If I click on it, you will see pipeline event log details, materialized view, and flow SDP has planned in DLT, blah, 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 blah. And if you see the JSON, you will see everything listed here. So it is saying incremental. If I see the data, I have 6 records, makes sense. Source sales is this one. Columns, okay. Table matrix, this one. So if you see output records are 6, yes. And it was incremental. That means it applied incremental load. Even if you see the output record 6, it doesn't mean like it processed all the 6 records. No. It is outputting obviously all the records because we are querying all the records, but it processed only the new records, only the 2 records. Wow. Make sense? Okay, good. Now, it's high time to talk about the streaming tables. Now you will say, Ansh, Lamba. Sometimes we do not even need to throw all the records. We just want to get the new data only. We want to get the new data only to just throw to the downstream. Okay. To throw to the downstream. Okay. Makes sense. So let's try to do one thing. Let's try to change this source from materialized view to streaming table. Okay. And let's keep this as is and let's keep this as is. Okay. Makes sense. I hope you're getting my point. So what we are trying to do. Obviously, we will be creating the new tables. Don't worry at all. Or we can just also use the same tables. It's not a big deal because this is like append only thing. So now the point is we will simply mimic this thing, but the source will be streaming table. Streaming table is nothing but a table which is built using Spark structured streaming, which guarantees idempotency. Now, what is idempotency? Idempotency means exactly once. That means it will only process the data once. It will not process the data after that. If it has processed data, that's it. It is not like I will try to load the data incrementally. If it does not, I will simply recompute everything. No. Streaming table means true idempotency because it is built on top of Spark structured streaming. Make sense? So let's try to read a little bit more about streaming tables. So if I go here in the overview tab, so basically streaming table is a delta table with additional support for streaming or incremental data processing. A streaming table can be targeted by one or more flows in a pipeline. That is a different thing. That means like within the same table, you can just use multiple tables to put the data, and I will just show you how, but that is out of scope, don't worry. Streaming tables are a good choice for data ingestion for the pipe for the following reasons. Each input row is handled only once. That means idempotency, which models the vast majority of ingestion workloads, that is by appending or upserting the rows in the table. They can handle large volumes of data of append only data, obviously. Streaming tables are also good choice for low latency streaming transformations for the following reasons. Because low latency, plus it is built on Spark streaming, plus it can handle idempotency, true idempotency. Makes sense? And we have the code, don't worry, I will just write the code for you. But this is a very good example. This says, bro, let's say you have the input row number 1, row number 2, row number 3. Let me increase the size. Perfect. So let's say row number 1, row number 2, row number 3. So the name is this, name is this, name is this. So this is like time interval T0. This is time interval T1. This is time interval T2. So you can see that we have got a duplicate called this. So it will not process it. It will never get produced because row 1 has been seen already. So it is like true idempotency. True idempotency. Materialized views do not guarantee you true idempotency because this is a batch incremental ingestion. But streaming tables mean continuous streaming ingestion, which you do with your Spark structure streaming using checkpoint folders to take care of idempotency. So that is why if you are using streaming tables, you will get the output as well only for the new data, because that is called the Spark structure streaming output, right? So let's try to create that. So what I will do, I will simply go to folder. Okay. And this is first tag. Let me just click on clone. Okay. And I will clone it and I will make it as, let's say, second tag. Okay. And let's clone it. And I will use my second tag and I will comment out my first tag because I don't want to run it anymore. I will say second tag, and what I'm going to do in this, I will create a streaming table. Now, if you want to create a streaming table, you need to use a decorator called table. That's it. And obviously we will be just giving a new name. We will simply say source sales and we will simply add stream. That's it. Okay, stream. And then let's change the name here as well. Okay, makes sense. Now, you cannot read a streaming table using spark.read API. You have to use spark.readStream because that's what you do with your Spark structure streaming as well, right? So same thing. You can read the table as a streaming now. So this is a streaming table. This is what? This is a streaming table now. Okay. So let's try to create on-rich sales. Okay. And I will simply say stream. And this will be a materialized view because I want to create a materialized view. No need to worry at all. Okay. So this is right. And, or you can say, yeah, or let's do one thing. Let's create the streaming table for this as well. So I'll simply say dp.table and on its sales and then stream it. So what will happen? It will incrementally pass the data to the second stage. And at the third stage, we will simply create the materialized view because we just want to apply aggregation, and for aggregation we do not need to worry about, you can say, your streaming, because we are simply saying, hey, we just want to append the data. And you cannot use streaming tables here. Why? Because you are aggregating the data, right? So you can change the data as well. What does it mean? See, Now here, you are not actually you are not actually modifying anything. You are simply inserting the data. For streaming tables, the behavior is append only. Append only. Everyone, append only. This is very important, bro. The behavior is append only. You can only append the data to your streaming tables. Okay, I will show you how you can just apply upsert, but for now, just keep this thing in your mind that without any special decorators, you can only append the data. But if you will apply group by, obviously you will change the data, because let's say for the same day you got some more sales, value will be changed. So this is not like append only behavior. This is update. This is upsert. So that is why you cannot create streaming table for this purpose. So that is why you have to create the materialized view, because we are doing the grouping. But with streaming table, it will throw the error. It will simply say, bro, how I can just perform the grouping on top of this thing? Even if it will not throw the error, you will not get the desired result. Why? It will perform the grouping on the basis of the new data only. And instead of getting the desired result is what? Desired result is what? Only 4 rows, right? You will say 4, not 4, 6. Bro, 4. Because when we inserted the data, see it here. When we inserted the data, we use the same time frame, we use the same date, 3rd or 4th. And in the view, we are simply aggregating the data on top of the date. So now if I query the data here, let me show you. And let's do it. You will see the difference live. So if I query the data now, select asterisk from SDP catalog.target.curated sales. I will see only 4 records. Okay. Let's see. Okay. 4 rows. Tum. Okay. Okay. Makes sense. So I am seeing only 4 rows. Why? Because in the second iteration, we added the data for these 2 days. Simple. For day 3 and day 4, or maybe for day 1 or day 2, you can just check the code. I think we added the data for day 1 and day 2. Yeah. So for day 1 and day 2, we added the data. Makes sense. So that is why you are simply seeing only 2 records. Only 2 records. Wow. You are seeing just the 2 records. Make sense? Make sense? So what it did, it recomputed everything. Why? Because it was required to perform the aggregation. It was required to perform the aggregation, and it cannot perform aggregation on the new data. No, it has to perform the aggregation on like everything. Make sense? Make sense? But for the streaming table, you will see that behavior here. Let me just show you. So let's try to create a streaming table here as well, and you will see what I'm trying to say. So let's say dp.table curated sales stream, and let's say stream read stream. Okay. On rich sales stream, and here as well source sales stream, source sales. Yeah, perfect. So let's say dry run, and you will see like what I'm trying to say. Okay, so currently we have 6 records in the source. If you remember, we have 6 records. Let me just show you. We have 6 records, 1 2 3 4 5 6. Perfect. Okay. And then we're gonna add some data for the same days, and you will see that it will not aggregate everything, it will simply append it. That is why it is a common saying that I will just tell about that thing. Just be with me for a few more minutes. Pipeline initialization failed. Okay, what is the error? Just tell us the error. Target.onRich sales stream. Wow, very good spelling. Stream. Dry run. No worries. No worries, bro. No worries. No worries at all. No worries. Okay, perfect. We have the graph. Let's run the pipeline. Let's see. And by this example, by this demonstration, you will get the crystal clear understanding of the 3 major components. Okay, so now it is running. Output record should be 6, obviously, because we have 6 records initially. Very good. We have 6 records here, and we have 6 records here as well. I'm so sure. Not 6. because we just have like 4 unique days. So it will simply apply grouping and it will simply give us the output records as 4. I think so. Let's wait. Let's wait. Okay, perfect. Output records 4. So now what I'm going to do, I will simply insert 2 more records. Okay, I will simply say 7 and 8, and let's try to insert the data for the same day. Okay, for the same day. And before doing that, let me just show you curated sales stream, like what's the current picture of that, and you can just take a note of this picture because it will be changed. So for 1 we have 210, for 2 we have 420, and 3 and 4 we have these things. Okay, so now what are we gonna do? We gonna insert the data, 2 more transactions here. Okay, so we're gonna insert these 2 records. Okay, and if I see the current picture of the source, we have 8 records. Perfect. Okay, perfect. Let's try to run the pipeline for one more time. You will see okay, let's wait. Let's maintain some suspense. Let's maintain some suspense. Okay, so now it is running. I think it should output 2 records only. Okay, perfect. It outputs just 2 records. 2 records, and let's wait for this one. It will also output, I think, 2 records according to my understanding. Let's wait. 4. Okay, this is the turning point. Okay, first of all, let me just tell you what actually happened. So basically we got only the 2 records. Okay, and this is really interesting, and this is the confusing point, and I intentionally created the confusion because you need to understand this, because this is confusing. So we got output records as 2. Make sense? Okay, very good. So what it did, it simply applied the streaming on just the new records, just 2 records, not 6, not 8, nothing, just 2. Then it forwarded 2 records. Okay, makes sense. It forwarded 2 records. Then when it reached to the next step, the last step, it needs to perform the aggregation, obviously. And just telling one thing, it is built on top of Spark structured streaming. Makes sense? In the Spark structured streaming, we perform grouping as well, right? We all know that. And it's called stateful transformation. So that is why if I now query this table, this one, I think the name is this one, right? Curated sales, what was the name? Yeah, curated sales stream. So if I query this, you will see only 4 records instead of duplicates. Why? Because of stateful transformation. Yes, it processed only the new records. It only outputted 2 records, but at the end, it performed the grouping using the stateful transformation. That is why you are seeing the results as is. But it guarantees incremental data. Why? Because this is built on top of Spark structured streaming, and it's a default behavior of streaming, which is called exactly once, which is called idempotency. And behind the scenes, it uses checkpoint folder to do that. That is why you are seeing output records as 2 instead of 8 or 6, because only 2 records are new and 2 records are going further. And at the end, it is applying grouping on top of everything because of stateful transformation. Make sense? Make sense? Make sense? So it is handling everything under the hood. Okay. In case of, you can say, materialized views, you see output records as all the records, but it doesn't mean like it processes all the records. No, it processes only the incremental data, but obviously it will output all the records because that is just a query. Materialized view is just a query with the cached results. So it simply adds those 2 records within that cached results, and it will pass on only 2 records, but it will show you 6 because it is the output of the data. It is the batch incremental ingestion. Batch incremental ingestion, not the real streaming. And It will not guarantee incremental ingestion every time. It will try to do that if it will feel like, hey, let's recompute the data, it will recompute the data. Make sense? But streaming will not recompute everything. No. It will never recompute data. It will only process the new data only. Make sense? Make sense? So these are your top 3, or you can say major components that you build within the SDP. Now you will say, Ansh Lamba, can we build a materialized view on top of the streaming table? Yes, you can do that, but reverse is not true. Because for the streaming table, you need a streaming source, and materialized view is not a streaming source. It is just a cached result, right? It is just a query with some records. It is not a streaming, it is not an append only behavior. Make sense? Because it can change, right? So you can create materialized view on top of streaming table, but reverse is not true. You cannot create a streaming table on top of materialized view. Make sense? Make sense? And what if we want to create if you want to use a view for our source? For that, you can create a view. It's fine, because views are of 2 types, streaming view and batch view. Okay. So you can literally say like this. Let's say you want to create a view here. So you can simply say dp dot temporary view. Okay. And you can say view like this, and it will create a view which will just hold the query. That's it. But just remember that this view should read the data like a stream, because you are feeding the data into a stream. Make sense? You are feeding this data into a stream. That's why read stream. But if it is a materialized view, then you do not need to write read stream, just read. So just create the temporary view accordingly. Make sense? Make sense? Okay, good. So this is all about your key components of the SDP. Make sense? Okay. So now I want to show you something. If I go to settings and if I go to YAML, like I have both the option, I can also see JSON, I can also see YAML, but YAML is like mostly used. So now you will say, Ansh Lamba, yes, whatever we have within this particular code base is using only this catalog and this schema. Where's the schema? Schema is this one, target. How can we change that? Let's say we want to deploy this to QA environment, to prod environment. You can easily do that using asset bundles, and in asset bundles, you can change this configuration in the YAML file. And if you want to learn about asset bundles, I will highly recommend you to just watch this resource. It's called Asset Bundle Ansh Lamba. Okay. It is a full course on asset bundles, how you can just use it. And in that video, I have also shown you that how you can just create DLT YAML file to deploy it to multiple environments. Okay. So you can just watch asset bundle, because asset bundles is the best way to deploy your code to multiple environments. Okay. So you can just watch this YouTube video as well. Amazing video. And yes, make sense, make sense, make sense, make sense. Okay. So now this was a like very high level and very basic overview of all the components, and obviously more you will try, more things you will learn, more things you will explore. That makes sense. But I also want to talk about some cool features within this SDP, which makes it even more popular, or you can say the first choice for the developers, because it takes care of all the errors as well. What does it mean? So let's say you will say, Ansh Lamba, what about the schema failures? What about the quality checks? What are those things? So for that particular thing, we have something called as expectations. If I open this Apache Spark documentation, obviously you'll just look at these cool things, which is called creating tables in for loop, which is like nothing, which is like you are just creating multiple tables in one go using for loop, which is just a kind of play thing. You can just go and just check it out. Not a big deal. And we have covered all these things. Okay, we have covered this thing as well. We have covered this thing. I will just cover this thing after expectations, not need to worry. And I think, okay, now I think we have this area. Now we can just explore this thing, because this is the most important area, which is called flows. Like not just the flows, but the special flows, I would say. Special flows. So now we're going to talk about these flows, and the number one flow that will be discussed right now is the append flow. Append flow. And what is this? Let's talk about it in detail and you're gonna love it. And after that, we'll be just talking about slowly changing dimension type 2 as well and all the things and all the quality checks and all. So this is just like a beginning. We're gonna discuss a lot of things. Okay. So let's try to create basically your append flow. And what is append flow? Let me just tell you. So now let's talk about append flow and let me just open the documentation for append flow. Append flow is amazing thing. Okay. And you will be using append flow a lot because append flow goes very well with sync. What is sync? Sync, remember the sync, the fourth component of the DLT or not DLT like HDP. So let me just find the documentation for that. Manage pipelines. Where are flows? So yeah. Chain capture. No, not really. I think in the developers. Yep. Append flow. I would say even before explaining the stuff, you should be able to understand this by just I would say looking at the keyword append flow. Do we have a good diagram? I would love to see. No, let me just show you. So what happens with append flow? Let me just open an online. What is, oh yeah, online paint. Yeah, perfect. So let me just draw something. So let's say you have a table. Okay, let's draw it here. Let's say this like this. You have a streaming table. Okay, streaming table. Perfect. Now this streaming table is your end table. Okay, okay, makes sense. Now you have source 1. Okay, you have source A or source 1. You have source B or basically source 2. You have source 3. Make sense? Very good. Very good. Now what we're gonna do now, oh my hairstyle. Yeah, fine. Okay. So now what we're gonna do, our end goal is we need to push all these 3 sources in the same table. Interesting. Do they have same schema? Yes, we can imagine that they have some like same schema and everything is same and everything is like compatible to push the data into the same table. Make sense? For example, let's say even if the same schema is not same, let's say we are just building some streaming tables on top of it. Let's say I am building a streaming table on top of it. Okay, to apply some transformation so that I can just flatten the schema or I can just make the schema as it is. Okay, so I'm doing this thing as well and I'm doing this thing as well. Make sense? Okay, so this is my stream 1, this is my stream 2 and this is my stream 3. Make sense? Good. So these are my 3 streaming tables that I am just creating. So now what I will do, I will simply create an empty streaming table. Yes, this will be an empty streaming table. Okay. Oh, this is like too neon. It's fine. Empty table. Now what I will do, I will simply say, hey SDP, I want to push this data to this table. I want to push this data to this table. I want to push this data to this table. Basically what I am doing, I am simply appending the data or basically appending the flows, because remember, this is one flow, this is second flow, this is third flow. Now I am saying I want to append all these flows into the same table. This is append flow, and this is only and only possible with the help of this decorator. It's called dp.append flow. Because you cannot say, hey, just create, like, you cannot say like this. Let's say, hey, just create dp.streaming table or dp.table, and you can just simply create a function. No, If you do that, it will create a dedicated table for that. Let's say this table for this, streaming table for this, streaming table for this, and you do not want that, right? What do you want? What do you want? You will simply create a kind of empty streaming table, and you will use this decorator to route your data to this particular streaming table. Make sense? Make sense? This is the powerful decorator where you just want to use multiple sources, multiple streams to append the data to the same table. Wow. This is literally wow. Make sense? Do you want to see the code? Let's see it. And let's also cover the documentation because I want you to just see everything. Okay. So do we have anything good? Obviously, we'll just cover the code. It's not a big deal. So not really. So it's fine. That's why I opened my paint. Okay. So let's say now, if I just look at, let's create our DAG, and let me just create let me first of all comment it out. Okay. Let me just comment it out and let me just create a new file. Okay. I'll simply say create file. So I will call it as append flow. Okay. It's fine. Good. Append flow.py. Good. So now what we're gonna do, we're gonna create 3 flows, or let's say 2 flows, just for the simplicity. Make sense? Good. Very good. So now what we're gonna do, we'll simply first of all import the DP. DP means declarative pipelines. From PySpark, import pipelines as DP. Perfect. From PySpark .sql.functions, import asterisk. Good. So now what table we gonna use for this particular purpose? We'll be using same table, let's say sales, or let's create different tables so that you can just understand better. Okay, I know like you need to look at the code as well. So let's try to create the scenario like as is. So what I'm gonna do, I will simply create this table. Okay. And do you know what? I'm so hungry right now. And if I eat something in the video, that you will say, bro, why do you eat it in between the video, blah, blah, blah. So I just had a little bit of Pepsi. That's it. And 1 oats bar. Okay. Ansh, focus on this first. Then think about something to eat. Okay. So let's create our sales. So let's say this is the sales for North region. What did you say? North region. Okay. So now we are just trying to create a table called sales North. Because let's say in our organization, we have different regions, North, South, East, West, and this table is capturing all the sales for North. Make sense? Very good. And let's try to insert some data. Okay, let's try to insert some data and we will simply say 1, 2, 3, 4. 1, 2, 3, 4. Perfect. And sales North. Make sense? Now let's create a table for South. Okay. South. Okay. Makes sense. And yeah, perfect. And we can simply say 5, 6, 7 and 8. Okay. Let's try to run this. Let's create 2 tables for now, but you can just create more and more. And because this is a real-time use case where you can say you are getting the data from different sources and you are simply dumping data into the same table. Now you will say, hey, why can't we simply use union? That will also do the same stuff, bro. Let's say for the North sales, you are receiving the updates on a daily basis. For the South sales, you are receiving the data or basically sales on maybe hourly basis. So you do not need to, let's say, perform the union between those data frames. You can simply run the pipeline and it will only and only process the new data for that particular region. That's it. That's it. And there can be like so many use cases. This is like very basic use case so that we can understand what is the end goal, right? There can be so many use cases. So our data is ready. So let's try to do that. So I will simply create a streaming table on top of the north table, and I will create a streaming table on top of the south table as well. So Ansh Lamba, currently the scenario is this: north and south. Yes. And we want our data to be available in this table. Let's say total sales. Yes. Do we have to create a streaming table on top of these first, and then we need to apply the, you can say, append flow? Not really. Not really. This is just a kind of transient step. This one. This is just a transient step. If you want to ignore it, you can ignore it. It's not a big deal. So that means we can directly create an empty streaming table, okay, and we can directly load this data to this particular streaming. Yes, you can do that. Let's try to do it. Okay, so first step, what did I say? You need an empty streaming table, right? So let's try to create that. You will simply say dp dot create streaming table. Make sense? So now you will just give the name. So let's give the name, let's say total sales. Make sense? Total sales. Do we need to add decorator like @ sign, or it's fine? Let me just quickly check the documentation. I doubt if we need to just do that. No, we do not need to do that. So I just created this streaming table, and I can simply say creating empty streaming table. Okay, this is empty streaming table. That means there'll be no function within that. This is just empty. Now we need to create a function, right, which will read the data from the north sales. Okay, I'll simply say def north sales. Okay, and this will do df equals spark dot read dot table, and this will read the data from the table. Let's say spark dot read dot table. Oh, okay, it's fine. SDP not sales. no, SDP catalog dot source dot not sales. Yes. Makes sense. And I'll simply say return df. I do not want to apply any kind of transformation. I just want to dump the data. Now you will say Ansh Lamba. Yeah, this is just a function. Yes. Now we need to use the append flow. So now I cannot write like this. Let's say @dp dot table. dp dot table. Why? And by the way, I need to use read stream. Just a typo. Yeah, I cannot write like this. Let's say dp table not sales. Why? Because if I do that, it will create a dedicated table for it, right? Now we know that, right? So what we need to do, we will simply say, bro, append flow. What? Append flow. Okay. Now in the append flow, we are specifying that we need to append this data to a flow, to a streaming table. Now we need to define the target. We will simply say target equals total sales. See, and let me just remove this. See, so now what will happen? The output of this table, which is return df, will not create a streaming table. No, it will append this data to this particular empty streaming table. Why? Because I'm using the append flow decorator instead of using @dp table or whatever. And let me just write dp as well. Like this. Okay. So now I am saying that you need to append this data. Make sense? And what was the table name? North sales or sales north? I think it is sales north. Okay. Sales north. Okay. Same thing. I want to do it for, you can say, appending north sales to the total sales. Understood? 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 Simple. Let me just show you the graph for it. If I say dry run, and you will see that now we have this thing. So now what it is doing, it is only creating this table called total sales. Now it is not creating multiple tables. Make sense? And this total sales is getting the data from the two tables, right? Like this. Like this. Make sense? Do you want to run it and make sure like it is running fine? So let me just click on run pipeline. And in the end table, we should see all the 8 records from 1 to 8. Okay, let's see. So this is the power of append flow, that you can just make the changes and you can just append the data into your end table. Okay, so it is running fine. Type equals to streaming. Okay, target the schema. Okay, perfect. Everything ran fine. So let me just check the data. SDP catalog dot target dot total sales. It should return all the 8 records if everything is fine. Okay, otherwise, yay, we got 8 records. Perfect. Perfect, perfect, perfect. So now what will happen? If let's say if I add some records to the north sales, I will get all those sales as well in my total sales because I am just appending the data to the same table. That's how you use basically the append flow. And if you just see, using multiple flows to write to a single target, this is the same stuff, but they are using SQL, but we are just using like pro thing, Python. Okay, but yeah, concept is exactly same. Okay, make sense? Very, very, very good. Make sense? Make sense? Okay, very good. So now, now you also understood the concept of, you can say, append flow, like how we can just use it. Okay, and why it is so powerful. Now let's take care of another flow, which is called, any guesses? Any guesses? Any guesses? It is called auto CDC. This one. Now just a disclaimer, auto CDC flow is not available in the open source Spark Declarative Pipelines. It is only available with Databricks. But the good thing is, in the real world, obviously you'll be using Databricks to run your SDP in most of the cases. So you need to know about auto CDC as well. Got it? Very good. Now what is this auto CDC? And this is my personal favorite as well. If you will ask me, what is the favorite thing of declarative pipelines? Like what is that thing that you love the most about SDP? Auto CDC. Auto CDC, auto CDC, auto CDC. Why? Because it is my love. It is my love. It is my love. Because do you know what? I do not need to write the code for slowly changing dimension type 2. I do not need to write the code for slowly changing dimension type 1. And I am talking about streaming code. I'm not talking about batch code. So just imagine the power of this particular thing. I do not need to write the function called for each batch and just try to apply the logic for upsert and then slowly changing dimension type 2, marking the records as expired. Nothing, bro, nothing. You want to love it as well. And let me just tell you how we can just use it. And first of all, let's discuss about auto CDC. And for that, you need to go to, I think, yeah, here. Go to develop pipelines and then you can go to flows and then change data capture. Concepts, perfect. The auto CDC API. In the DLT, we used to call it as apply changes. Okay, apply changes. But now we have renamed it to auto CDC. What is this? This simplifies change data capture. Okay, make sense? Okay. Now I will not talk much about this particular API. I will just show you the results because you wanna be like, wow, man, like this. Trust me, this will be your moment very soon. So now, if you're a data engineer, you should know about slowly changing dimension type 1 and type 2. If you do not know, first of all, slow claps, very well done, very well done. That's why I say like choose your mentors wisely. If you do not know about slowly changing dimension type 1 and type 2, let me just tell you. We can also use the examples here for the demonstration. And we can also go to Wikipedia to read about it. But I think I can just explain you that slowly changing dimensions like this. like this, like this, like this. Let me just explain you what are slowly changing dimension. Let me just open my paint. Okay, I love drawing because I know one thing is presentation, like whatever you are just showing. Okay, this is my personal point of view. Personal point of view. Point of view is always personal. So you can say this is point of view. No, this is my point. Okay. Fine. We are not studying English. Okay. So this is my point of view, my personal point of view. Okay. So now what the thing is, our brain is developed, is grown in such a way where when you see someone explaining the stuff live, you can understand it much better. Instead of just showing you the visualizations, instead of just showing you, let's say, the fancy that thing that looks very cool, but it's not about just looking cool. My main intention is just like making you understand the stuff. So that is why I put more efforts to explain everything on the fly, explain everything in the video itself instead of just preparing those animations, because I know from the aesthetic point of view it will look cool, but my agenda is just to make you understand the stuff. Okay. Yes, it requires some extra efforts to draw everything live and just keep a note of everything what you need to draw or what you need to explain within that drawing. But it is worth it because you grow better, you learn better with this approach, and that's all I want. Okay. So let's try to understand the slowly changing dimension type 2 as well, or basically slowly changing dimensions first of all. So let's say you have this table. Okay. Let's say you have this table. And in this table, you have some fields. For example, let's say this is a products table, very common table. Let's say you have ID, you have product name, you have price, you have category, you have, let's say, discount, not discount, not discount, let's say subcategory. Okay, perfect. Now for ID1, for ID1, the name is, let's say, what do I need? Let's say bike. Okay. Price is, let's say, $10,000. Okay. $10,000. Still cheap because bikes are expensive here. Like it depends like which bike you wanna buy. Okay. So category is, let's say, vehicle, and subcategory, let's say, two-wheeler. Okay. Then we have second, and we have, let's say iPad. Okay. Price is, let's say, 500 because of Black Friday. Okay. Category is gadget, and subcategory is, let's say, subcategory is electronics. Yeah, whatever. Okay. Oh, electronics X. Wow. Yeah, there was like no space. I cannot put like C and S both. Okay, so X. So the third product is, let's say, notebook. Okay, notebook. Okay, and the price is, let's say, $3. Category is stationery, and subcategory is, let's say, paper, whatever. So now this is your dimension. Okay, this is dimension means like one of the table which stores all the contextual value about your products. Make sense? Like whatever products do you have in your store, in your company, you just create a dedicated table for it. Now let's say after 1 month, okay, after 2 months, you want to change the price for, let's say, bike. Now bikes are expensive, right? So now the price you want to keep for bike is, let's say, not actually price, because we do not store price, to be very honest, in the dimension tables. Okay, so you can just ignore price and you can simply say color. Okay, or just ignore this column for now. Let's say you want to change the category of it, or you want to change the subcategory of it, or you can say you want to change the name of that product. So you do not want to call it as bike, you now want to call it as, let's say, super bike. Okay, Harley Davidson. It's love, man. Harley Davidson, like, it's a vibe. Who is saying Bullet? I am a Harley Davidson lover, so not a big fan of Bullet. So yeah, superbike. So now superbike. By the way, I do not have any Harley Davidson, but I do like that bike a lot. So now, superbike. They now want to change the name from bike to superbike. Okay, they now want to change the name of this thing from bike to superbike. Now they cannot make the change as is. They have two options. Like they can either make the changes in place. In place means they can simply change the name from bike to superbike, or they can create a new record for it. So for example, earlier they had, let's say, bike. Okay. So let's keep the column same and you can just adjust the header. Okay. So earlier the name was bike. Okay. And whenever they just change anything, they store or basically keep the audit for it. This bike name was actually created at some time, okay, when this table was created, and ended at, or basically ends at, okay, or expired, whatever. So this bike, let's say this table was created in the year of 2020. So I will simply put the date 200101, and now today the name of this bike is changed. So 2025 01, not 01, today is 29th 11 29th. Okay, so now what will happen now, it will add another record. It will call it superbike, and it was created at 2025 because this is a new record and it just entered in the table today. Okay, and what is the ends at? It will be null. It will be null or a very big date, let's say 99990101, because it is still in use. So this is called as slowly changing dimension type 2, which is the mostly used type of your dimension category, where you store the logs. You say, bro, do not make the in-place changes because there is no way to track those changes. If I want to track the changes, I will simply say bike was the initial name, but it was expired at 29th of 11 2025. But we have a new record called superbike, which was entered or basically created at this date, and currently there is no expiry date or expiry date is very, very big and it is not going to expire very, very soon. But we do not know about the future, but so far, like for this particular point of time, it's not expired. That's how you store the logs. This is your slowly changing dimension type 2. Now, in order to create SCD type 2, you need to perform a merge statement at least 2 times. You need to flag the records as like expired multiple times, and you need to do a lot of hard work as well. Okay, you need to then optimize your code, and forget about optimization, bro. In order to just write the code, you need to spend so much of time. And now we have auto CDC API. It will take care of everything, literally everything. So now we can just understand this thing using the official documentation. So let's say this is the table. Let's say this one, user ID, name, city. Okay, so if I made any change to, let's say, this one, name is Mercedes, city is Tijuana. Okay, now in the same name I change the city, Mexicali. So it is saying starts at 5 because it ends at 5, and now it ends at 6. Why? Because there's a new name for Mercedes called, like city for Mercedes called Guadalajara. What is this? In which country do we have the city? So Guadalajara. Okay, so this is the city for Mercedes now. Let's say this is the headquarter for this. So now this starts at 6 but ends at null. Why? Because this is the current value of this. So that means this is the log, the entire history of the Mercedes product. And now we are not simply changing the in-place changes. We are simply storing the logs as well. Make sense? Make sense? Make sense? I know If you have built slowly changing dimension type 2 in the past, you know the pain, how long it takes to create that. And it's not just about building those things. Then the second step is optimization and obviously so much of other things as well. But with the help of auto CDC, you can literally convert your 300, 400, 500 lines of code into this code. Let me just show you and you will be surprised. That's it. Boom. Your 500 lines of code is now condensed in just hardly 10 lines of code. Wow. Anshlamma, will it take care of all the sequence? Will it take care of all the operations? Will it take care of this, that? Yes. 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 It will take care of everything. Wow. Wow. Okay. So this is the code for slowly changing dimension type 1 because we can see it. What is the code of slowly changing dimension type 2? It will be very, very big. I'm so sure. Bro, do you know what is the difference between the code between slowly changing dimension type 1 and type 2? Do you want to know? Let me just show you. So this is the code for type 1 and for type 2, exactly same. You just need to write here 2. Everything else is same. Whoa, this is amazing, bro. This is amazing. Yeah. Yeah. So are you excited to implement this? Because once I will be just implementing this, you will understand better. Okay, let's try to implement it. And let's actually try to create a source table for this. Let's try to create a products table. And then we will be creating slowly changing dimension type 1 and type 2 both. And then we'll be just making the changes in the source. And then we will see how it just handle, how it handles those changes. Okay. Are you excited? Are you excited? I am very, very excited for this. Let me just do that. So for now, I will simply write a text and I will simply say h3 and I will simply say slowly changing dimensions. So let's create a source table. It can be, let's say like this, stp catalog dot source dot products. Okay, dot products. Okay, so first of all, product ID, product name, category, and then price, not price, bro. We do not store anything in the dimensions. So it will be, let's say, subcategory. Perfect. And then very important column, date. Okay, date or update date, because on the source side we get the update date. Okay, updated or basically updated at. Okay, updated at timestamp. Make sense? Let's insert some records, subcategory, and I want to insert the date as, let's say, current timestamp. Yeah, let's do it. Because we are inserting the data now. Okay, so I just want to keep it real. And 4 products are fine. Perfect. Let's try to do this and let's query this table as well, just to see like what do we have in the source table. Okay, good. Okay, we have 4 products, we have 4 values, like with 4 updated date. Okay, makes sense, and we are good with this. Okay, now we want to create a slowly changing dimension type 2 for this. Okay, let's create that. So I will create another file and I will comment it out. Okay, and let's try to create not clone, let's create a new one, and I will say auto CDC. Okay, auto CDC. Perfect. So now for the auto CDC, first of all, import it from PySpark, import pipelines, and from PySpark .sql .functions import asterisks. Okay, perfect. Now what we need to do, the first step is same. Why? And like what is the first step? The first step is very simple. We first of all need to create an empty streaming table. Yes. Okay, so let's create an empty streaming table. Empty streaming table. Okay, so at the rate dp dot let's call it as products std type 2, because this is std type 2. Okay, and let's create a function products std type 2, and let's say df equals spark dot read stream. Okay, oh, this is empty streaming table, right? Oh, okay, so we just need to say dp dot create streaming table. Okay, and then just call it as, let's say products std type 2. Make sense? Okay, and we can import it as dp. Okay, perfect. So now we have the empty streaming table. Now what we need to do, we need to simply create a source table. Now what this is the source table. This source, not exactly the table, we can also create a view, because see, let's say this is our source. Okay, this is our dimension. It is a good practice. We should always have one transient layer between this. Like we can directly create this thing. It's not a big deal. We can do that, like directly build storage changing dimension type 2 on top of this, but we should always create a kind of transient layer. Transient layer is like temporary layer between these two steps. So what I will do, I will simply create a streaming view, not a streaming table, just a streaming view. Okay, sorted. So let's create that. So I'll simply say, which will do nothing, which will just bring the data for our slowly changing dimension type 2. That's it. So streaming view source. Okay, so I will say dp dot temporary view. Okay, and let's say def yes, products std2 source, or I can also say product source, because we'll be just creating type 2 and type 1 both. Product source, and I will say df equals spark dot read stream dot table, and table is stp catalog dot source dot products, right? Okay, what I will do, I will simply say return df. Make sense? And let's create empty streaming table for std type 1 as well. Perfect. Okay, now this is our source. Source is ready. Now what we gonna do, we gonna create slowly changing dimension type 2 and type 1. Okay, and for that you can simply copy the code that is written here, because code is just the same for both. So you will simply copy this code, which is a kind of decorator, not decorator, it's just a function which is called dp.create auto cdc flow. When we created dp.append flow, we use a decorator, if you remember. See, dp.append flow. But for auto cdc, we do not need to use any kind of at the rate. Okay, because this is not actually a decorator. This is a function in itself. Make sense? Within that, it uses append flow within that. Okay, but like it uses decorator within that, but we do not specify it because it's a function in itself. Make sense? It's a kind of API that it calls. Okay, so now we need to define the target similar to append flow. So target is this one, right? Products std type 2, because we are first of all creating std type 2. That's it. Source is this one. Source is what? This one, product source, right? Perfect. Now key column. What is the key column in our case? If I just go to the table, it is called product ID. Key column is basically the primary key. Okay. product ID. Make sense? Now sequence by column. This is very important. This is the column that decides the order in which it needs to expire the results, and it is nothing but updated at. Make sense? Because the more recent data, that means the newer the data is. Okay. Then apply as deletes. Let's say we also want to apply the deletes on our data, because in the end table in the storage changing dimension, we also want to delete the delete the records permanently, but we are not doing that. So we can simply ignore this code. Then accept column list. Let's say in our end table, we do not want this updated at column, because it doesn't make any sense to just store this column because it is coming from the source side, right? So I can simply write it here, updated at. Okay. So this will not be available in my end table. Yes, you can also pick the columns. And I want to create a storage changing dimension type 2. Okay. SCD type 2. Perfect. Similarly, I will create storage changing dimension type 1 as well. And the only difference is just say it 1. That's it. That's it. This is your storage changing dimension type 1 and type 2 both. And you know what? In order to create only one type of storage dimension, you need to write 300 plus lines of code. And if you are just creating both, then at least it would go around 800 to 900 lines of code. But here, simply hardly 30 lines of code. And even after adding comments and so many spaces, if I remove this, it will be like, let's say 20 lines of code. Oh man, amazing. This is my favorite part. Let's say dry run and let's see if everything is fine. And then I can just show you the end result, because you will not see the power of it until you see the end result of the table, because it will create all those special columns that we want to create. And by the way, it is saying, what is this? Cannot have multiple queries named this thing. Oh, I know that. What is the issue? Because we need to rename it, because this is products SCD1. Perfect. Dry run. So for the same table, for the same source table, we are creating 2 dimensions. Okay. So let's try to see the DAG. Perfect. So this is a DAG from the same view, which is the streaming view. It is creating products SCD type 1 and type 2. Make sense? Are you ready to run this? Let's try to run it. And you will be amazed by looking at the columns that it creates automatically, which is called starts at, ends at. We do not need to create that. We didn't create those columns, but it will create those columns for us. And I will just show you. Don't worry at all. Don't worry at all. So see, now what it will do, it will simply output the records, right? Okay, perfect. Now what will happen? Let me show you the source code first of all. If I just show you select asterisk from HTTP catalog.target.type2, you will see that, wow, we have everything. We have our original data. We do not have updated at column because we dropped it. We have start at, like at what time it started, ends at as null because it is not ended, it is still in use. But we will just make some records to be expired. So what we're gonna do, we want to make some changes for our product 3. Let's say product 3's category is changed to category 4. Make sense? This category is changed to category 4. So now how we can just make those changes? How? Obviously, whenever we use any kind of source, it would be, let's say, transactional data source, right? Database or anything. So we do not make inline changes there. We just simply add the records. Okay. And just treat it as the changes. Make sense? Make sense? So what we're going to do, we will simply add the changes. So I will simply say, so let me just comment it out because we do not want to create the table again. I will say insert into products, and I just want to insert only and only 3 with current timestamp. Okay. Let's try to do that. And let's see the result. So what will happen? Okay, error. What's the error? Oh, colon, semicolon. Okay, so now let's see the data. So now in our source, we have added this new record and we forgot to just make the change, but that was intentional. Why? Because I want to show you the power of this sequence by column, and just wait and watch what we're gonna do. Now I will simply say, let's say category 4. Okay, now let's see what will happen. Okay, and now I want to make one more change. Now I want to say subcategory 4. Ansh Lamba, what are you doing, man? You are making the things complex. You are adding more and more challenges for SDP. So what? So let's say now what happened? Now we have 3 more records, right? 3 more records. Yes. Now let's say these 3 transactions are added into the source table. Now the current value for 1003 is this: product 3, category 3, subcategory 3. What is the most recent state of 1003 is this one, category 4 and subcategory 4, because of this timestamp, because this is the latest one. But we still need to store these 2 values as well, as you know. Make sense? So what it will do, it will automatically add these 2 values and it will make them as expired based on this sequence by column. That is why we passed this particular parameter, that sequence by, that you need to decide the order for the most recent value based on this particular column. Are you excited to do this, to run this data flow again? Let's run it. Let's see how it will handle that. Let's see. So now let's see what will happen. I'm also excited. Okay, I'm just testing it out and I think it should handle that. If it does not, let's see like what's the issue. Okay. That's how you learn, right? This is data engineering, baby. So let's wait. And this is the source. It will bring only the new records. So it is saying upsorted 1. This is the in place changes and we all know that. This should upsorted 3 records. Very good. 3 records. Let me just show you the current state of the table. If I query this thing, you will see perfect. That's I wanted to see. So now if you look at the table, we have 3 values for 1003. And here we have the most recent one with category 4 and subcategory 4, because ends at is equal to null. That means it is currently in use. But the other values were expired based on the timestamp. See, the first value, the most you can say the oldest value was this one, category 3 and subcategory 3. Then we got this as updated value, category 4 and subcategory 3. Then it was also expired, and this is the latest state, which is called category 4 and subcategory 4. Okay, so it handled everything. And if I just query slowly changing dimension type 1, which is a kind of in place changes, so you will see only and only the latest value of it, of product 3. Wow, man, literally wow. Can you feel the energy? Like, can you feel the, I don't know, man. Like, if you are not feeling this, there are 2 possibilities. Either you have not developed slowly changing dimension, you have not written so many code for slowly changing dimensions, or I don't know what are you doing. Because I don't know, like, what is, if you cannot feel the power of this thing, what you can do and what do you want to feel the power? Bro, this is really game changing thing. Okay, so this is the power of auto CDC flow, and I hope that you loved it, because this is my personal favorite part as well. And this is already changing the dynamics of data engineering. Make sense? So now I hope that you know how to build slowly changing dimensions using SDP, which is the most important thing. Now I want to talk about something called as expectations. Okay, expectations. So now we're gonna just learn about expectations, and expectations is my second favorite thing in declarative pipelines. And I would say it is equivalent to if I just compare the scale, I equally love auto CDC and expectations, because it actually takes care of all the things. And you know what, if you are a senior data engineer and if you are someone who takes care of all the data quality checks, because junior developers will not be taking care of those things, you need to take care of those things. So if you are someone like that, you want to love expectations. And I love the diagrams and the documentation for expectations, especially because they have just demonstrated that thing very in such a way that you can understand it by not even just looking at the definition, but by just looking at the diagram. Let me just show you. That's my favorite as well. So if I just show you the expectations, so this is the expectation data quality. Wow. And it is so straightforward. Let me just tell you. Can we zoom it? No. Why? Where is the magnifying glass for it? Let me just zoom my screen. Yeah, perfect. So now what happens? So bro, whatever we are doing so far, we are not considering any kind of quality checks. What can be the quality checks? For example, if the data or if the record is null, if the record has some, you can say data integrity issues, if the record has some data quality issues, whatever, we are simply processing everything. But in the real world, we do not want to do that, because it can break our code, it can break our data warehouses, it can do a lot of stuff, right? Yes, we can apply some manual logic to manual, you can say, filters to remove those things. But what if I tell you that you do not even need to do that as well? SDB will take care of those things as well, called expectations. Now this is the kind of thing that I also need to check if expectations are available for now, because see, SDP is newly added in Apache Spark. So obviously in future, more and more features will be available in the open source Apache Spark as well, but it is shortly available in Databricks, but I am not sure if it is available in open source Apache Spark. But if it is not, I think it will be available very soon. If not, again, I will repeat the same stuff. You will be using Databricks to do the PySpark, because Databricks is everywhere right now and it is leading the curve. So just rely on Databricks. So now what happens? So basically, let's say you are loading or basically processing the data. Let's say this is your raw data. Okay. Now you define a kind of expectation. Expectations are nothing but rules. Okay. You define some rules that, hey, you do not want any kind of nulls in that column. Hey, you want all the values greater than 0. Hey, you want all the things like this. So you defined kind of rules. Okay. If like what is the possibility after you define the rules? Either rules will pass or fail, obviously. So if it passes, if those rules are passed, obviously you need to keep processing and you need to do your stuff. If that rule is failed, then you have the ability to take an action. And there are 3 actions available. Number 1 is warn. That means you will simply send the warning and you will keep on processing the data. What did I say? You will send the warning and you will keep on processing the data. That means that record which has failed the expectation will still be the part of the processing, but a warning will be there. But if you decide to take the action as drop, what will happen? That specific record which failed the expectation rules will be dropped from the table, and other records will be processed, will continue to be processing. Now this is very critical. Let's say you cannot afford a warning or drop. You need to immediately fail the entire execution. Then it will throw the error immediately. It will simply say, bro, that's it. Fail the flow right now. Okay. Okay. This is your expectations. Okay. Okay. Now in the real world, we do not define only one expectation. We define multiple expectations. We define what? Multiple expectations. Okay, so if you have multiple expectations, we have an updated, you can say, chart as well, which will take care of multiple expectations. Perfect. So let's say you have a group of expectations, let's say multiple expectations. So if all the expectations are passed, then it will be the part of the processing. If any of the pass, or basically any of the expectation or rule is failed, any, let's say you define 100 expectations and 99 are passed, only one is failed, then also it will go to the action, and again same stuff, warning, drop or fail. Wow, very well done. Make sense? Okay, so now what we're gonna do, we wanna just look at that thing practically. So now what I will do, I will create a table, new table, and let's create a new file. Let's say create file, and I will create a file name, let's say called expectations. Okay, expectation. By the way, we can also add the expectations to the existing tables as well. It's not a big deal. Okay, but let's try to add the expectations here. So when we want to add the expectations, what will happen? Or we should just try this one. Because we can create the expectations and we can just add it here as well. Okay, but just to keep the things simple so that you can just understand it, let's create a new file. So let's create this file as from PySpark dot import pipelines SDB. Perfect. So now I will define some rules. Okay, so rules are, it will be a dictionary, by the way. So I'll simply say rule 1. Okay, rule 1 is, let's say product ID is not null. This is my rule number 1. The rule number 2 is let's say yeah, updated at is not null. These are my 2 rules. If I get anything failed for these 2 rules, I want to take an action. Okay, so let's try to create a table, and let's try to create, let's say, a streaming table, dp.table, and name equals, let's say, expectation, or let's say products table. Let's call it as products table. Okay, so now I will simply create a products table, okay, which will read the data. Let's say df equals spark.read.format. Okay, spark.read.format, and then I can simply say, hey, not format, table, right? Spark.read.table. Okay, makes sense. So what will be the table? Table will be SDP catalog dot source and then dot products. Make sense? Return df. Now I will show you that where we need to adjust the expectations. Just hit enter, and just before the table, you will simply say at the, not at the rate, I think, yeah, dp dot expect all, and then you will simply pass the rules. Now you will say, Ansh Lamba, where did we take the action? Because we simply said these are the rules, but what if I want to take the action for warning? So if you say expect all, that means you are saying do not do anything, simply send the warning, and that's it. Okay, if I say expect all or drop, then I'm simply saying if it does not pass the rules, simply drop the records. If I say expect all or fail, that means it will simply fail the flow. So here is the action. If you do not write anything, then it will be warning. I can also show you in the documentation. So if I say this is expect, okay. See, expect all or fail, and then they are simply using the inline rules, but I prefer writing a dictionary because it is more readable and it promotes more readability. Make sense? So you can simply write like this, expect all, and they're also using dictionary in the later version. So you can also do that. Expect all or drop and expect all or fail. Make sense? Very good. So now let's try to run this. And we gonna insert some records with the null product IDs. Let's try to do that. Let's not add the ID here. Okay. And let's see. Okay. Where is the null? Cannot write, not enough data column, target table. Okay. Let me just say null. Okay, so now we have null product ID. Now let's try to run this particular thing. Okay, what it will do, it will simply send me the warning and that's it. Let me just click on run pipeline. So let's wait, and what it is doing, oh, so it is running my, I think, auto CDC as well, because did I comment it out? Yeah, I didn't comment it out. So it is running this as well, which it should not. Otherwise it can just throw some errors because of null. So we do not need to worry about that. Let me just comment it out because we just want to focus on this one. So if you see this one, if you see products table, which is our current table, you are seeing one warning. You are seeing what? One warning, right? See, you are seeing one warning. View data quality. And if you just expand it, you have one warning. If I click here, you will see that rule 1, action is allow and fail. 12.5% records are failed. That means one record is failed out of 9. Failed records 1. But it didn't drop anything. It simply sent me the warning. But if I let's say insert one more record as null, okay. If I insert one more record as null, okay, now this is a new record. Now if I just run this with the new expectation, if I say, bro, expect all or fail, then it will fail the flow. Okay. Now if I run this, it will not run it. It will simply fail it. And in the drop, it will not count that record and it will simply drop that record and it will process the rest of the records. Okay. So now you will see the error. And that error is the intentional error because we want to see. Okay. So it is running now. Let's see, failed. So it is saying failed to meet the expectation. That means it did not follow the rule. It did not pass the rule. So that is why violated expectations, you can see it, and that is why it failed the flow. That is the power of expectation. And it will take care of everything. And that's how you create expect all or fail, or basically rules here. And if you just want to create, let's say, your expectations for the empty streaming tables, because in case of, let's say, auto CDC, you create empty streaming tables, right? So how you will define the expectations there? Then we have the parameters within this. So if I just uncomment it, you will see that within here, I can pass it like this. Let's say expect all or fail. And then I can define that thing, that what is my expectation. I can simply say rules like this. Okay. And I can even show you, I think this is also available in the documentation. If I go here and if I say developers create auto CDC flow, or let's say create streaming table. So you will see that, oh yeah, see. So you simply say dp.create streaming table and then you will simply write expect all and then your rules. expect all or drop rules, expect all or fail rule. So you define that expectation within the table definition itself, because you cannot write the function obviously for the empty streaming tables, right? So this is the power of expectations, and you can just manage the data quality as well on your own. You do not need a dedicated team for data quality checks. You do not need a dedicated developer to do the data quality checks. No, now you can handle everything on your own. That is the power of expectations. And I hope like this is a good one, right? You would have loved it. Okay. So now I want to talk about, like, there are not much topics left, but this topic is very, very important, because you will say, Anshlamba, whatever we are doing right now, we are doing it in a static way. But in the real world, we also use parameters. For example, if you just want to add any parameter, we use widgets, right? Is there any way we can add those parameters here? So the answer is yes, we can do that. How? We can use Spark configuration to get the parameters. So let me just show you that as well, because that is also important. So for example, let me comment it out and let's create a new file. Create file, and let's say parameters.py, or let's say just parameters. So now let's say I want to, let's try to run a loop. Okay, let's try to run a loop, because I think there was a loop here. Yeah, where is that loop? Yeah, in a for loop. Okay. It is not a very good example. I can create, I think, my own example. Yeah. So let's say the scenario is very simple. I want to create a so let's say I have a list. Okay. List of table. Let's say table 1, table 2, table 3. Okay. I need to create these 3 tables, or not these 3 tables. I have a source. Okay. Same source, but out of the same source, I want to create 3 tables. Okay. And these 3 tables will be created using this loop list. And this will be fun. Understood the requirement? So we have this list. We need to create the 3 streaming tables, but based on this list. So we'll be just defining the table name and everything using this list. Make sense? So for that, we need to create a parameter first of all. So if you just want to create a parameter, you can simply go to settings, and here you will go to configuration, and here you will add a key value. Let's say I will say tables list. Okay. And here you can just simply pass the value. The value will be simple. You will say, let's say A. Okay. And then let's say like this, A, and then B, and then let's say C. Okay. This is your list, A, B, C. Let me just say save. Make sense? So now you have this particular configuration. Okay. Makes sense. Now you have this list, and now obviously you cannot use widgets. Really, yeah. You cannot use widgets, especially in DLT, like declarative pipelines. So you cannot use widgets, but how you will just work with the parameters? That is a challenge, right? Because first thing is you need to first import the parameters. And if you cannot import the parameters, how you going to just use it? So that is the first challenge. The second challenge is how you just need to run a for loop. Make sense? Getting the scenario? Like, why are we just creating this? So first of all, you need to understand one thing. Whatever we create in the configuration, whatever, let's say list, obviously that list will not be a normal list. No, that will not be a normal list. That will be a string list. Oh, okay. Yeah, that will be a string list. So you have to first of all get the parameter, and that parameter will give you the list in the form of string. Then you need to convert that list using a special function called literal eval. Literal means constant, like literal value, and then eval. And we use it with the help of AST module. AST module. Make sense? Make sense? Make sense? Are you getting my point? Are you getting my point? Okay. So let's see it. Okay. So first of all, we will simply get the parameter. Okay. Spark using Spark configuration. And then we need to convert it using AST module. Okay. So how we can just do that? I will simply say from PySpark import pipelines as DP. And we also need to import AST. AST module is used to convert that list, string list, into a normal list. Okay. So let's try to first of all import the variable. So variable will be, let's say, list variable will be spark.conf.get, and the parameter list is like, what was the name of the parameter? Okay, tables list. Okay. If I show you, if I say print list var, let's see what happens. Let's see. I can also do this rough work in my explorations just to make the use of it. And I think that makes sense. Let's use this area. Pipelines are expected to have at least one table defined, but no tables are defined. Yeah. Because it will simply say, hey, define something, blah, blah, blah. Okay. So now in order to do this, you can either create a new Python file just to see like what is the output of it, but it's fine. It's fine. Like I have already tested it out, so I know what will be the output of it. Makes sense? Okay, so now what we're gonna do, we will simply say list of var. Now we need to convert it into a list. So I'll simply say list of var of list equals AST dot literal eval and then list variable. So what it will do, it will convert this string list, because this is a string list, into a normal list. Make sense? So now we have the list. Now let's run a loop. I'll simply say for I in this loop list var list. Okay, so now within this loop we will be creating multiple tables because that is a requirement. And how we can just do that? It's very simple. I'll simply say @dp dot table. Okay, name equals f string, and I can simply say I, not I basically. I will simply say table and then I. Make sense? Basics of Python. So what we did, we simply used the f string. We simply used the f string to create our table name. So it will simply say table underscore I, and what will be the value of I? A, B, C, and it will be just keep on doing this thing. Make sense? So this is our table name, and this is our table name. Okay, perfect. And now let's create a function. Let's say table, and we do not need to give the same name here because we are simply providing the name using the constructor, using the destructor, using the decorator. Okay, table. I'll simply say df equals spark dot read stream dot table, and table, as we all know, the table is same. Table is nothing but sdp catalog dot source, or let's say dot what source we should pick? Let's say sales. Make sense? It will simply say return df. So if I run this, if I just show you the dry run first of all, what it will do, it will just run a loop over all those objects and it will create multiple tables, and each table name will be based on this particular I variable. That's how you can just run a for loop and using a variable, like variable on top of your parameter. So if I just show you the DAG, you can see like table A, table B, table C, all the three tables are created. How? Using the for loop, including their name is unique. See, it is not the same name. So that's how you can just run a for loop on top of your basically list, and you can create dynamic tables using dynamic table names and everything dynamic. That is the way to do it. Make sense? That is the power of parameters. And you can obviously work with so many parameters, but this is the main stuff that you would need to do it. Make sense? Make sense? Make sense? Make sense? Now what's next? The next thing is obviously scheduling. So once you have everything ready here, once you have created the pipeline, now some of you will say, Ansh, Lamba, it's good, it's amazing. Now just tell us the way how we can just include this particular development as part of our other development. So for example, you are creating, for example, a Databricks job. And in your Databricks job, you have SQL scripts, you have Python notebooks, you have so many other things. And you need to make this particular pipeline as the part of your Databricks job to orchestrate it, to schedule it. How you can just do that? So let me just show you. That is a very good question. So for that, you would first need to go to, let's say, home. Okay. And then you can just go to jobs and pipelines. And then you can create a job. If you click on create and then click on job, not ETL pipeline, this time is job. So let's try to create a job. Let's call it as, let's say, job. Okay. And then click on another task type. Okay. So here you will search for pipeline, ETL pipeline. And here you need to pick the task name. So let's say SDP tutorial and type as pipeline. Okay. Then you need to pick the pipeline. So now this is your pipeline. Just pick this pipeline and you can say, okay, now I want to schedule this. If you want to add retries, you can say retry. I want, let's say, at least 2 times. Okay. I can say at least 2 times you need to retry and confirm. And that's it. If you say create task, now this has become the part of your job. Now you can have, let's say, more and more tasks. You have, let's say, SQL script. Let's say you have multiple notebooks. Let's say you have multiple pipelines as well. Let's say you want to create one more pipeline. You want to schedule one more pipeline. You can orchestrate everything within the job. Now, some people can be confused, like what is the difference between a job and a pipeline? Because both are doing the same stuff. No, both are not doing the same stuff. ETL pipeline is just doing your data engineering stuff. It's just doing your building your streaming tables, building your materialized views, and that's it. But in your job, you can have so much of other stuff. You can have a wheel task. You can have your SQL script. You can have literally anything. But in this ETL, you can just be having streaming tables, materialized views, and that's it. So do not be confused. You can say ETL pipeline is just a subset of a job. It's just focusing only one part, one kind of activity. But other tasks are also there for which you need ETL pipelines, right? For which you need ETL jobs, not pipelines. I am just looking at you, bro. You just need to see. It's not very difficult. You just need to pay attention. If you need to just build only the pipeline, build the streaming tables and materialized views and all of that stuff only, you will go with the ETL pipeline. Once it is done, once you need to create more tasks, more activities along with this ETL pipeline, you can create a job, which will be the real orchestration formula for your, you can say, whole development. Make sense? Make sense? Make sense? Make sense? Do not make it complicated. So now the good thing is you have covered all the things that you need to know for this particular amazing add-on in the world of Apache Spark. And I'm really happy that this framework is here finally. And this is gonna change the dynamics of big data engineering, I'm so sure, and data engineering, obviously. Why you need to feel happy? Bro, if you have mastered this particular framework now, because it's almost 2026 now, you gonna be that outlier because you can flex this skill in your resume and you will see this skill very soon in the job description, because you can already see these kind of skills available in so many job descriptions, but this will be skyrocketing very soon. So if you know all of these things, very well done. Okay, and I'm really happy that you loved this video. If you loved this video, just drop a lovely comment on this video right now and let me just tell you your next steps. You will be saying like, okay, this video is done, like what we actually need to do next. Next, you need to build a Databricks project, and you can also watch the Databricks tutorial first of all if you haven't watched that. You already have the resources. Let me just tell you for one more time. If you just want to master Databricks, simply search Databricks and then Ansh Lamba. You will find Databricks full course Ansh Lamba. You can watch this video, which is modern Databricks, and you can watch this video. If you watch both these videos, you will become a master of Databricks. Okay. Just watch these 2 videos of Databricks, then go with the projects. Try building projects. I have built amazing projects, and you can actually go to GitHub repo to just find that thing. If you go to Anshlambacollab Git, if you go to repositories, if you go to, let's say, data engineering roadmap, which is specifically built for those who want to become a data engineer from scratch. So if you just scroll down, everything is there, by the way. This is the complete roadmap, and you can just see where do you actually stand right now, and you can just watch all the other stuff as well. Everything is available on YouTube. Everything is available for free. And if you just scroll down at the end, you will see that we have this particular section, dedicated section for projects. This section will cover all the projects. Now you can just pick any project of your choice. You can simply, you have like 1, 2, 3, 4, 5, 6, 7, 8 projects so far. Every project is using Databricks, and you can just pick any project. Every project is unique and solving some real world challenges, and actually building complex solution which you will actually build in the real world. Make sense? So you can just pick any video. Each video is unique. Now you will say, Ansh Lamba, how many videos do we need to watch? More projects you will build, more skills you will gain, because each project will help you gain some amazing skills. Okay. So just try to complete, or basically at least complete 2 to 3 projects. You will be able to crack the jobs in the world of data engineering, I'm so sure. Okay. And again, everything is available on YouTube. So you are good. Make sense? So that is all about your next steps, and I hope that you will love this particular roadmap. And yes, you have the next steps ready, and just go and cover this roadmap as soon as possible. And happy learning.